industry. And from there, he identified that hacking and unauthorized internal disclosures as the most common causes of cyber issues and healthcare data issues. Odieni Ital 2027 examines security challenges also in what we call the remote patient monitoring systems. So in the remote patient monitoring system, highlighted the vulnerabilities of patient data due to poor security implementation and limited empirical evidence on adding that 2017 that when you look at any organization with a comprehensive security training program, experience significant fewer data breaches as compared to those with minimal one. So when you consider an organization where they do more of training in security, they do more of security awareness, this is able to reduce the security incident in their health data. And when you look at how Ethel in 2023 proposed a 3-tier security measure, and so he was saying that when you want to look at the security of these things, it shouldn't be only 1 tier, but 3 tiers. And so in these 3 tiers, he was talking more about data encryption. He talks about the elliptic curve cryptography, then also the blockchain. And so when you talk about the encrypting of the data, the encrypting of the data will help us address the real-time issues. And when you talk about cryptography, cryptography also helps us in the transfer of data from one place to the other place. And the next one is the smart contrast. And so in the smart contrast also help us to address issues related to privacy. So Jal et al. 2024 reviewed various technologies and methods employed to enhance the security and the privacy of medical data within health information system and highlighted the challenges within. So you look at the health information systems, and so based on the health information system, look at the various models and various things within the health information system and see what are the security issues that best need to be addressed. And Teheldo et al. In 2024 suggested that machine learning algorithm can improve intrusion detection system by continually adapting a new attack. So from here, we can talk about the SVM. The SVM as a machine learning will really help us to do more of intrusion detection. We can talk about the random forest also helping us in our prediction anytime that we are using this system. So what are the protocols that we used in this whole exercise? And so the objective was to synthesize the evidence of data security challenges and also propose some mitigation strategies. The scope was a digital health system. So we're looking at a lot. So we look at about 6 digital health systems. The health, electronic health record, we look at the mHealth, we look at the telemedicine, we look at the telehealth, and we look at the wearables and other ones. The period. And so we consider the 10 years period because within the 10-year period, that is where most technology in terms of security has really matured, and most systems have also adopted digital tools and digital initiatives in transforming healthcare. Peer-prepared were reviewed, and this was done in English. So the methodology, we use the PRISMA 2020 compliance protocol. The PRISMA 2020 compliance protocol is a standard one, which gives us the option to be able to identify, to do some more screening, do eligibility, and also can perform some inclusions from there. And it helps us in our reporting channel. Then when you look at the framework also, we adopted the pickup framework. So in the pickup framework, we talk about the population being the bigger picture at the digital health system. We talk about the intervention at the mitigation strategies and some of the challenges that we do. We do more of comparison to compare systems to find out, and we now come out with some outcomes. So the databases, 12 databases were searched for this information, and we did LVUs, we do the IEE, we do the Explore, we do the Web of Science, and a lot of them. Then we look at the PRISMA 2, and so the PRISMA 2 full diagram is also there. And so as part of the research, we use the mixed method appraisal to 2028 to assess any biasness and also the quality of the data. And in this case, also the analysis were more of narrative synthesis. Narrative because the data was heterogeneous, different systems were being considered, so it wasn't prudent for us to use the metadata analysis in our search. So this is the Prisma architecture that we use in the entire exercise. And so in this Prisma architecture, we just look at the identification. So in all, we identify about 168 data, and based on 168 data, we're able to remove all the duplicates from the data. And we use a Zotero in removing all duplicates. And we look at some documents that are ineligibles in the foreign countries, different languages that we can't even have access to them. And we consider the excluding criteria from the whole process. So at the end of the exercise, we use about 90 papers for this particular systematic review. So this is a frequency distribution of the database that we use for the entire exercise. So we have the IED there, Institute of the Electrical and Electronic Engineer. We have some document also from the Sprinter. Then we have those from the Korea Science, Natural Medicine, and a whole lot. So we have a percentages of them, and the highest is coming from the I3E of the 41%, and the least one is also coming from the Information Resource Management Global, which gives us 1%. The findings. So for the search findings, using the Peacock approach and also applying the MMAT model, we were able to have 8 strains that we review. And so out of these 8 strains, it came out with the various findings. So the first one was the total of the 168, that is initial search. Then after applying the rule, we had the 128. After that, we have the 101, and last one that we used for the entire research was the 90. So the findings, and so with respect to question 1, looking at the threats, looking at the challenges in data security. And so when you look at the left-hand side, the first column talks about the key study, and we labeled our article with just a code for us to easily understand. So we call L1. When you see L1 on my left-hand side, it corresponds to the third column, identify threat. So it means that that particular paper talks about unauthorized access and breaches. When you look at something like L10, it corresponds to the insecurity data storage, poor encryption. And so from these papers, that is 29 papers in all, we were able to identify again all the threats that are within the health data. Then from the research question 2, looking at machine learning and also looking at the security. And we can see that on our left-hand side, giving us the papers, we have L38 and L39 talking about one thing, user authentication and behavior profiling. So when you come to the L26, it talks more about malware detection and behavior modeling. And so these are some of the papers that came out. And from there, we were able to tell the data type, and we were able to talk about the deployment, in what context area, where was this system used. Then the third one, for the research question, talks about the mitigation strategy. So from the mitigation strategy, this one will refer to the first column. The mitigation strategies are there. And we can see a place like the L67 talks about multi-factor authentication. And we can look at L39, talk about the RBAC, and talks about the policy as well, and talks about federated learning. So these are the papers that give us much method or strategies to address these challenges. So looking at our fake home from here, from our findings, we realized that a key finding highlighted a critical need for implementing adaptive context-aware security framework. So when we talk about a context-aware security framework, we are looking at a framework that is able to develop to address issues based on what we see, and it's also more advisable for countries with less resources. Poor data storage practice and unencrypted transmission have negatively also influenced the digital health system. And to mitigate this one, we talked about the machine learning models, enhanced threat detection. Then we can talk about our SVM that helps us in intrusion detection. We can talk about the random forest that helps us in our prediction. Then their integration with cryptographic and also decentralized technology provide a more robust and multi-layer defense. So we are not talking about only one defense, but there is a need for us to combine multiples of strategies in order to address this healthcare data that we are talking about. In conclusion, to effectively address the agent data security issue, healthcare organizations must employ multiple coordinated security measures at the various levels. A combination of security measures like the encryption, access control, network security, regulation, and monitoring systems can create a comprehensive protective structure that reduces vulnerability and better safeguard sensitive health data. So this is a sample of the articles that we use in our systematic literature review. So on my left gives me the article code, and also it corresponds to that particular references. And here are some references that were used in the systematic literature review. Thank you very much.
Please give him a round of applause. All right, so it will be time for questions. We're just taking 2 questions, one offline, one online. So if you have a question offline, please put up your hand so I see you. Okay, there's no question offline. So how many people online have questions? Can you check for me? No.
Okay, I have a question.
Okay, so 1 question online, and then we can move on to the next speaker.
Okay, so that was a good review. The presenter is advised to also consider certain mathematical algorithms that run these security recommendations. Because as much as it's a security gaps that has been highlighted in the various review that he did, there are a lot of protocols out there. Its implementation is a problem. And so if the implementer does not consider what is recommended, then it means when you do your review, you are going to have a negative impact. Example, if you look at NEST, NEST has recommended an ECC curve, but practitioners are saying that they don't want to run their protocols on the NEST recommended curve. But that is a major risk. If you don't consider NEST curve and you run your algorithms on other ECC curve, you are going to expose yourself to attack. And so if a developer decides to run an algorithm on an ECC curve that is not recommended by NEST, definitely your review will capture ECC implementation as a failure. And so it's advised that he also considers some of these recommendations. But all the same, it's a good review and a good observation. Thank you very much.
All right, thank you so much. So let's give it up once again for Hammond for a nice presentation. So those of us who are offline, those of us in the auditorium right now, there's coffee and tea outside whilst the presentation is ongoing. You can have a coffee or tea with some biscuits, and I think there are some fruits as well. And then there's also some candies around just to keep you sharp whilst the presentations are going on. So our next presenter is also an MSc student with the department, and he's going to speak to us on the topic Federated Learning for Cross-Bank Mobile Money Fraud Detection under Ghana's 2025 Draft Open Banking Directive. Federated Learning for Cross-Bank Mobile Money Fraud Detection under Ghana's 2025 Draft Open Banking Directive. And the presentation is going to be made by Michael Tetete, who is an MSc student, and he's here with us. So without wasting much time, let's give it up and clap for Michael as he gives us the second presentation. Thank you very much. So whilst he's setting up, those of us offline, if you want some tea, some coffee, once you exit the door to your right, you would see a setup where you can have tea, coffee with some biscuits. Yes. Thank you very much. There's one.
you go to, let's say, Bank of Africa, whatever is happening there is independent of what is happening in GCB, EcoBank, and the rest of the RFIs we have in Ghana. So these banks operate in silos, which also limit the effectiveness of cross-institutional fraud. We have seen cases where a fraud that occurred in EcoBank, after a number of years, another bank like, let's say, ABSA, is likely to also see similar fraud. This is because they lack this cross-operational or cross-banking platform or functionality. And this is one of the gaps this research aims to resolve. Then we are also going to have one of the problems also is raw transaction data. Sharing raw transaction data across these institutions raises privacy and regulation concerns. There is a pressing need for privacy-preserving collaborative approach to fraud detection that aligns with Ghana's open draft banking directive from the Bank of Ghana. Now, my research questions. How can federated learning be effectively applied to cross-bank mobile money fraud detection in Ghana? And what are some of the privacy-preserving techniques that are necessary to comply with open banking directive? Then I also look at how does the performance of federated models compare to traditional banking approaches in detecting fraud. And I'm also going to look at what are the scalability challenges of deploying FL across Ghana's diverse financial institutions. Now, research aim and objectives. To design a federated learning framework for collaborative, privacy-preserving fraud detection among regulated financial institutions in Ghana, which includes all banks, the Universal Bank, the Rural Bank, the APS banks, mobile money operators, the savings and loan companies. And we also aim to evaluate the effectiveness of federated learning models in detecting cross-bank mobile money fraud compared to the traditional siloed approaches. And also aim to ensure compliance with Ghana's 2025 draft open banking directive regarding data privacy and security. Now, one objective of the open draft banking directive from the Bank of Ghana is to is data privacy and security. So this research also aims to solve that issue regarding data privacy and security. Now, what are some of the related works or literature review? A lot of work has been done concerning using federated learning for credit card fraud detection, for other financial crimes, but nothing has been done concerning mobile money fraud detection. Now, from Kairos et al. In 2021, they came up with a research that allowed multiple institutions to collaboratively train a model, a machine learning model, without sharing raw data. And that is the core objective of federated learning, allowing diverse and multiple institutions and organizations to train a model locally on their premises, then share data from these trained models to a central server where an aggregation is done using federated learning algorithms and models. Now, another review about mobile money fraud detection is according to Ajekum et al. In 2023, where machine learning has improved fraud detection, but most solutions are institution specific. And that is also happening. This also is regarding the traditional siloed approaches. Then open banking and PC regulatory frameworks like the PSD2 in Europe and Ghana's draft open banking draft emphasizes. This diagram is an overview of the federated learning architecture. Now, we different organizations that train models locally. So we can see the purple image here, which is talking about the model, then the data from these institutions. So each of these institutions trained a model independently on their basis. Then they now send the trained model, the data from these trained models to a server or a centralized location where an aggregation is done using federated learning algorithms and models. Then after applying all the models and aggregation, this aggregated data is now sent to the engineers for testing and model deployment, after which is now sent to the rest of the world for use. So applying this architecture for cross banks, when you look at the diagram, let's say we have bank A, bank B, and bank C. Assuming bank A is After Ghana, bank B is GCB, then let's say bank C is a mobile money operator, let's say a telecom like MTN, which does mobile money transactions and operations. Now, these institutions train a model using their own data, financial data. And this financial data includes transaction logs, transactions, and statements from customers, their personal information, the KYC customers, and transactional flows of customers. Now, the trained data from these institutions are then sent to the aggregator. Now, one thing about the models is that we are going to see in the methodology is that after training the model, data from the institution, we don't send the raw data to the aggregation server. What is sent to the aggregation server is the gradients or the parameters from this trained model. Then the aggregator then applies the differential privacy algorithm, which adds mathematical noise to the model. Then, in compliance with the Open Draft Banking Directive from the Bank of Ghana, the model is then trained. The global model is trained. Now, when you look at the second diagram at the bottom, this is the engineers let's say the testers and the engineers that work with the aggregator. After which the differential noise together with the global model, trained model, is then sent to the user, which is the rest of the world. Now, limiting it to the research, we have bank 1, bank 2, bank 3. So these models, like I illustrated earlier, the trade models or the updates or the gradients from these banks are sent to the aggregator, which is a server. Then we have the Bank of Ghana Open Directive applied together with the differential price that will be applied at the aggregation server to train the model. After which the train model then releases a global data that is then sent to the other banks or other institutions to share raw data with the user consent from the customers. They have a platform called OpenDS, which is the Open Data Exchange platform. So these raw data from the customers are sent to the exchange platform, where each and every institution connected to the Open Exchange platform, let's say Bank A, they use a standardized API to send and receive data to and from this Open Exchange platform. So with the help of this model, we are not going to only send raw data of users, but we are going to send aggregated data of users. So alignment with privacy and preserving the privacy of the customers. Now, to explain this, the conceptual framework for this research integrates the regulatory, logical, and operational components necessary for effective privacy preserving cross-bank mobile money fraud detection in Ghana. The core objective of federated learning is ensuring privacy preserving. Each bank now train models, unlike other machine learning models that every bank brings their information. Now, all the training is being done locally on the premises of each institution, which preserves privacy. Now, the methodology, we are going to have data simulation. So with the data simulation, we are going to use synthetic data reflecting Ghanaian mobile money patterns. I'm also going to a non-disclosure agreement with some of the financial institutions in compliance with the IRBs to ensure, according to the Bank of Ghana taxonomy fraud framework. With the model development, we are going to use a TensorFlow federated or a Python framework. Then with the models, we are going to use Compare ANN, Random Forest, XGBoost. And then with the aggregation, which will be done at the aggregation server, we are going to use federated averaging with differential privacy. Then with the privacy techniques, we are going to use the secure multi-computation for encrypted updates, then differential privacy to prevent data leakage. Then the evaluation metrics will be done using the accuracy F1 score, false positive rates, then in compliance with also the Bank of Ghana Open Banking Directive. Now the project is developed into phases. The phase 1, which is the data sharing and ethics. And like I said, going to finalize an agreement with 2 banks, 2 plus 1 payment service provider like MTN. Then we are also going to secure the RRB approval. And the date, we are going to use data from the Bank of Ghana Fraud Taxonomy 2024. Then with the picture engineering or data pre-processing, the purpose of this is to transform our data into a model into a form where we can now make decisions on it. So we are going to use models like apply machine learning models techniques like transaction velocity, graph centrality, minority class synthesis with VAE organ. With the VAE organ, we are going to use it to generate the synthetic data for the model training. And the tools we are going to use is PySpark and TensorFlow. Now, with the baseline models, these are going to be trained at each bank's premises. So we are going to use either XGBoost. The XGBoost is the extreme gradient boosting, or the light global boost machine. The XGBoost, banks, universal banks, banks like ABSA, GCB, with high computational devices are going to use the XGBoost, whereas the PSPs like PSPs with lower systems are going to use the light boost, the light GBM to capture the current precision and latency. The tool we are going to use is scikit-learn. Then the federated prototype, we are going to implement a Fed average using Flower. And we are also going to add differential privacy, stochastic gradient descent noise, and secure aggregation. And we are also going to perform these tests for 20 global runs to ensure accuracy and get the best output. And the tools we are going to use is Flower, which is a federated learning framework. We are also going to use Opacus and PySift. With evaluate banks, then the second layer, which is the aggregation server. Each local bank is going to have either the XGBoost or the light wheel gradient boosters. And why this fits in this project is because it's got with the XGBoost or the light global boost machine. It has a state-of-the-art, highly imbalanced tabular financial data. And it also requires a short training time, easy class weighing, and sharp-based feature explanations that regulators can read. Now, because of time, the second layer is the federated layer, where the aggregation is done. And we are going to apply the standard federated learning algorithm, which is the federation average. Now, the federation average works with any tabular learner wrapped in TensorFlow federated. And it uses a minimal communication cost, and it serves as a reproducible reference for future Ghanaian market deployments. So these are the 2 layers we are going to work with. The first, which is the baseline, which are the local banks, the second layer, which is the federated layer, where the aggregation is done. And what are the expected outcomes from this research? We are going to come up with a prototype, a federated prototype learning system for cross-bank fraud detection system. We're also going to have an empirical evidence on the effectiveness and privacy of federated learning models. And going to give us a recommendation for implementing privacy-preserving fraud detection system under Ghana's Open Banking Directive. The significance. With the technical impact, we are going to have a scalable FL, which is a federated learning prototype for Ghana's financial ecosystem. Also, with the regulatory impact, first, it's going to be the first federated learning framework explicitly designed for Ghana's Open Banking Directive. Example, applying the differential privacy noise levels tailored to Bank of Ghana's cross 2.1 on data encryption. This is also going to be the first federated learning research or work on mobile money fraud detection. Then with the economic impact, it has the potential to reduce fraud losses between 40% and 60%. That is going to enhancing consumer trust. Then novelty, this is going to be the first, like I said, first FL learning, federated learning implementation tailored to Ghana's regulatory and infrastructure context. So these are some references. You have the Bank of Ghana, the Bank of Ghana's publication of Bank of Ghana SDIs and the PSPs. The PSP is the Payment Service Providers Fraud Report for 2024. Then the draft Open Banking Directive for fraud for regulated financial institutions. This is an open document that when you go to the Bank of Ghana website, implementing an open banking system, then we as users, we should be able to know what is coming so that we have an idea, because your bank is going to share your financial data with another bank. So, and one advantage of this is that those who take loans and they don't pay, now if you take a loan from Bank A and you don't pay, they have your transaction record, which is also going to be shared to this open data exchange platform. And Bank B, Bank C will also have access to this data. So as users, this is something that the Bank of Ghana is coming up with that we should be aware of. So I would advise all of us to go to the Bank of Ghana website, download this draft Open Banking Directive, which was released in December last year, read it and have an idea of what is coming. So these are some of the references for the research. Thank you very much.
Yes, thank you. Right. Any comments, any questions from anybody? Those of us on Zoom, anybody in-house who has a question or two to ask him? Yes. Okay. Wow.
Please, I have a question.
You are not in trouble. This is to just encourage you. So we have two people online, and we'll take the one in person, in-house, before we proceed. So, please.
Gives me a little bit of worry, as in why you are using banks to do the federated learning rather than the mobile money. Unless, of course, you are trying to say that you are linking the bank account to the Momo account to deal with it. So that is one distinction that you have to clarify.
Okay,
the other one is that, let me finish so that you can. The other one is that, where is the aggregated server sitting? Is it sitting at Bank of Ghana so that when the banks go through their training and all that, then they will just push their trained data to the server at Bank of Ghana? Or which of the banks, where would that infrastructure, aggregator server, sit? I understand that you said it's a conceptual view, but in terms of real implementation, how will it be like? Then if I answer this, I add my last one.
All right. With your first question, when we talk of mobile money, because of the mobile money is let's say a universal word or phrase. Okay, banks also perform mobile money. You can buy airtime directly using it from your bank, using your bank USSD code. You can transfer money from your bank to another bank using USSD or the mobile application system or the internet banking platform. That's also mobile money. So when we say mobile money, you don't only limit it to the mobile transactions performed by either MTN, Vodafone, Telcel, or AT. Banks also perform mobile money transactions. And employed by these financial institutions, the RFIs. Because if according to the Bank of Ghana's open draft banking policy, these RFIs are going to use a standardized APIs, which means they have their systems on premise. Then they are going to use this API to send data to the OpenDS platform and from the OpenDS platform. So this model is going to be deployed on the individual RFI's computer. That is going to help identify patterns in this data that the institution is transferring to the Bank of Ghana OpenDS platform. Please, are you getting it?
Yes, I am. Maybe a suggestion.
Okay.
And something that you can look at, because I'm looking at where the aggregated server will sit, and there are a lot of issues in terms of who have the rights, access, and all that, because everybody is pushing their data to that particular server. The other suggestion I want to also give you is that perhaps we may also have to study the collateral registry system. On the collateral registry system, what we do is that for the banks, whoever goes in for a facility at the bank, some collateral details is taken, and it is stored at the collateral registry. Anybody at all who wants to access the facility, it is one of the compliance check that the bank will have to reference to the collateral registry to get those details to validate whether really you pass that risk test. Then they have. So I think your model is likely to that of the collateral and also the credit reference bureaus, the way they also operate. So maybe if you study that, you may appreciate the infrastructure demand that I'm talking about. But I think it's a very good work. And when you say mobile money, you are talking about the services that the bank performs.
Yes.
In transferring the money, it is a service, not necessarily mobile money. So we may have to look at the terms so that we come clean in the terms. But I think it's a very good work.
Thank you.
Thank you very much. I think we'll start with Dr. Clifford online. You also give us your comments, and then the respondent will follow.
Hello, can you hear me, please? Hello, can you hear me, please?
Yes, please, we can hear you.
Okay, thank you for your presentation. I want you to go to your architecture for the federated learning. I'm interested about the machine learning, the technical structures, because I'm not a social science, so I'm not interested about social science stuff. So let's go to because it seems there is some misunderstanding, and that is why the first person who asked a question was emphasizing about where the server would be. So I want some clarity. So if you can go to your slides and show me that slide where you have the framework of before I ask my question, if the clarity is clear, because I have some misunderstanding about the way you understand the federated learning. So I want you to give me some clarity, then I can pass my comment. Okay, thank you. So, because I heard in your presentation and in your answering, you keep on emphasizing that the aggregated server is that all the banks are going to push a data to aggregated server. Is that what you meant? I just want clarity.
Train a model locally.
I can't hear you.
I mean, each bank, let's say bank 1, is going to train a model locally with their financial
Don't worry
data.
about this training. Don't worry. I understand model training. I just want clarity about something. Just you, because I heard you repeatedly saying that all the banks will push a data to aggregate the aggregation server. Is that your point? I just want clarity on that.
Yes, exactly.
Then I cannot.
Yes, exactly.
And that means you may not appreciate federated learning perfectly. So you should read further. There is no data, just like you have in the heading, privacy preserving. No data move from the nodes like the Bank 1, Bank 2. It's only the weight that they have trained, their model weight. Because no data, privacy is the key thing about federation learning or differentiated learning. So no data go to what goes to the aggregation server is only the trained models, in other words, the weight. And the weight will be pushed to the users. So your understanding of federated learning, you should read further. No data. And that's why the first person who was asking the question was concerned about data and where the server will be. Because of there is no data, this server can even be at one of the banks. It's just like kind of a peer distribution system. So it's only the train weight that is moved to the aggregation server. If there is data moving to the aggregation server, then there is no privacy preserving, then there is no federated learning. So you are a master student. I will urge you to read further about federated learning.
All right, thank you. I think I'm sorry for the misclarification. If you look at the first diagram, like I said, it's the gradients that are moving, and I also explained that the banks are not going to send their raw data. They are only going to use the updates or the gradients. So I'm sorry for the confusion, but it's about the gradients. There's the gradient.
I understanding before asking the question, making the clarity. Because your next slide, you said that the data that is going to the aggregated server. That's why I wanted clarity. So maybe next time, correct yourself and the way you answer the question.
Yes.
Okay. Because you keep on data goes to the aggregated server and it's not the data. Okay.
Yes, sir.
And I have another comment.
Okay.
You said that Bank of Ghana have a central open exchange data, right?
Now, this is a platform that Bank of Ghana is creating. So if you go through the open banking draft, they are here to set up this.
I just want simple answer. As a master student, you should just answer the simple question. I need to give my thing. If it's not so, don't give explanation because I don't want explanation for that. I just want that you said Bank of Ghana is putting a platform that they call open exchange platform that all the banks will push their data there. That is what I heard. If it's not what you meant, then I leave it.
Exactly.
If that is what you meant, then I can make my comment.
Exactly. That's what the open draft banking directive is about. The banks pushing the transaction data of the customers and with the consent from the customers to the open direct DS platform. So that's
exactly. So if all the data is now going to be centralized and that's the data you are going to use, then what is the point of federated learning? Because all the data has now been accumulated on one place already. So the federated learning doesn't come in because federated learning, you want to preserve privacy. But here's the case, Bank of Ghana is building a platform that all the banks are pushing the data there. So because like if we say you are going to use that centralized data platform that Bank of Ghana is using, then it means that the data you are using is from the centralized platform. So in that sense, as a bank, I don't need to train any model and push it to anywhere again. Because you are using the centralized platform Bank of Ghana has created as a platform. So think about it. In that sense, federated learning doesn't come in, it's flop. So read further and think about it. If the data you are using, every bank is holding their own data, and they are using the data to train the model, then federated learning comes in. But if Bank of Ghana has made a rule, they have created a platform, all banks will send flawed data to that platform, and you are going to use that platform data to train the model, then no need for federated learning. It doesn't come, it doesn't fit the concept. So think about it and read further, okay? That's my humble suggestion.
Okay, right. So we will move on to the next. Wilberforce, you want to ask a question? Again, this is just a platform to improve on what we are doing. Let's take in the constructive comments and then do the next one. Okay, all right. So after Wilberforce, we have somebody in-house. Go ahead, Wilberforce.
So that was a good and then I want to know, because there are issues, I understand there are issues, and then security issues, and then security and privacy issue in federated learning, and so that's why maybe you want to use SMPC and then combine with the DP. So I want to know, SMPC, that's a multi-party computation, comes with a high computational cost, plus differential privacy. That one also comes with what computational. So how are you going to balance this? What techniques are you going to use in order to reduce the computational cost? Because SMPC, because of its computational cost, its applicability is very limited. But here in the case, you are going to add it to DP. And so how are you going to, what techniques, optimization techniques are you going to use in order to balance computational cost, privacy, and accuracy?
Okay, with the
Thank you.
baseline, okay, the baseline models are illustrated in the phase 2. In phase 2 of the methodology, the baseline model, for the, I said we are going to either SG Boost or the light GBM. With the light GBM, it uses histogram-based architecture or algorithms, which is light compared to the SG Boost. So I think with the RFIs that have low resource computing power, they are going to depend mostly on the light boost, because it's going to be compatible. Light boost, light GBM algorithm. Please, I hope that answers you. Hello?
Okay, thank you. Please, under your expected outcomes.
It's not really, but
Can I go ahead? Okay, yes, please, under your expected outcomes, I saw you brought a figure of fraud reduction between 40% and 60%. Please, how did you arrive at that value?
From my literature review and then from the GSMA State of the Industry Report 2024, it's a projection I'm making. That's why I came up with the 40% to 60% fraud reduction.
I think the question is, how did you arrive at that projection? Which metrics informed your projection? Did you just decide, because of this document, I'm projecting this, or what? This is academic research, so educate us.
It's a potential.
No, even in estimation, probability, we compute.
Yes.
So if you just assumed without any, empirical evidence supporting it, then make that clear.
We are going to use metrics like the
No, but right now you have projected a figure.
Yes.
How did you arrive at that? In research, you have to explain everything.
Well, I've not done the.
You've not done that?
Yes. So.
Then we cannot substantiate what you have presented. Do you agree with me?
I agree with you, but.
All right. All right. Now, in all of these, the purpose is to make sure eventually when you're having your Viva, you cover all these bottlenecks and make your presentation very rich. Any more questions for anyone? For him, from anyone? Oh, please, you see, we want to improve. I don't know whether he has an assistant who is taking all these notes. But if there is no more questions for him, right, we'll discharge our presenter. Please, let's give a round of applause. I always want my virtual applause, so please keep them coming. The virtual applause is very important to me. It is not easy. Yes, thank you, John. Thank you, Doc Clifford. Yes, we are seeing all of that. I need a virtual applause. Right, so we will quickly fetch our next presenter. A moment. All right, ladies and gentlemen, we have a Okay. Take it out completely. Okay. All right. So we have our next presenter ready. And he is in the person of George Henry Aqua, an MSc student. And his topic is an exploratory study of hallucinations in AI. Wow, some interesting topics.
Changed.
Yesterday it was depression.
Yeah.
Today is hallucinations. All right, ladies and
Please, it's been changed.
It's been changed.
Yeah.
Oh, okay. All right. So he's going to talk about transforming antimicrobial stewardship with intelligent technologies. I'm learning new things. All right, the floor is all yours.
Thank you, sir. Good afternoon to you all. Good afternoon, everyone, both seated here and online.
Yeah, okay.
My presentation today is on how we can use AI to mitigate something we call antimicrobial resistance. So what is happening is we all take drugs, antibiotics, and we've increasingly noted that the drugs are failing. So someone has a pneumonia, he buys some drug, maybe amoxiclav, and we realize that 2 weeks, 3 weeks, the situation is getting worse by the day. This phenomenon we call antimicrobial resistance. Now, antimicrobial resistance is responsible for the death of about 5 million people in the world every year. And when we put all the deaths from diseases in Ghana to include strokes, cancers, diabetes, kidney failure, and all, they don't add up to as much as the deaths from antimicrobial resistance alone. So it's one of our leading killers and a very serious phenomenon ongoing. Now, how does this come about? So bacteria over time, just like human beings, evolve ways to escape detection and in order to be able to survive. So various mechanisms, they grow receptors, so that when you give them the drugs, they extrude the drugs from the environment, they undergo genetic mutations to withstand this and all that. And what really pushes this is certain practices and attitudes of human beings, to include things like self-medication, people on their own prescribe drugs for themselves. And when these drugs are not working, the excesses get the microbes to mutate and do these things. Another thing too is bad prescription habits. Doctors sometimes prescribe drugs without really putting too much caution to see that is this drug targeting this organism. So they do what we call empirical treatment. So we don't know, you have a fever, but we don't know the organism, but we just presume, then we give you something. It may or may not work. This one also contributes to this. Right now, thanks to technology, thanks to AI, we could devise various means, various machine learning and deep learning algorithms can harness big data, and we could have data repositories, what we call antibiograms, from which we could refer to and make precise choices so that we limit antimicrobial resistance. So my presentation here today is to discuss how we could leverage machine learning to combat antimicrobial resistance. My name is George Aqua. I'm an MSc computer science student here. I'm also a public health physician at the Kolebu Teaching Hospital. So AMR, or antimicrobial resistance, as I rightly said, is a global crisis. It's expected to cause about 10 million deaths every year by the year 2050. The disproportionate burden of this is in lower and middle income countries like Ghana and some places in sub-Saharan Africa. And there's a need for context-relevant, intelligent technologies to handle this menace. Over-the-counter prescriptions count a lot towards these. So those of us who visit drugstores and then we tell them what we want, we've converted the drug shops into a supermarket. So instead of the pharmacist listening to your story and serving you, you go like, I want this, I want that. So these kind of habits promote antimicrobial resistance. Limited drug diagnostics for resistance detection. So ideally, you come to the hospital, you have a fever, we have to draw your blood, examine it, find out which organism and target the treatment to it. But this is not happening
partly because majority of the country does not have the labs. And from this map, about half of Ghana, the areas shaded white, do not have laboratory facilities. So then we can't even test to even determine the resistance in the first place. Now, there's variability in prescriber practice. Dr. A feels, well, malaria chloroquine will do. Dr. B feels it will be done by artesunate. Dr. C feels mefloquine will do. All these variabilities also contribute to resistance. Now, there are surveillance gaps despite all these measures going on. And one of the things that bars this through is the inavailability of the labs, because we cannot readily do tests. And even in the urban areas and the cities where the labs are there, the other thing too is cost. People can't afford these tests. So because of these, we treat without seeing, and this enables the parasites to do all kinds of things to escape that. Now, we can take a look at how we can involve technology. AI can offer scalable learning-based interventions, very wonderful ones, and there's a need for antimicrobial stewardship to move from being static to being smart. So as opposed to doctor thinking you have a fever and you need this, doctor should take that decision based on data, based on a data pattern or trend he has observed. And AI tools, machine learning tools can be very wonderful in that regard. They can be very resourceful. Even if patient wants to self-medicate, he or she should self-medicate based on some informed decision. Right. So how can AI help? AI can educate patients not to self-medicate. Our chatbots, ChatGPTs can all offer various advice on this. It can review prescriptions, predict and prevent AMRs, natural language processing tools can detect cues in a statement that points towards resistance. Oh, this patient was treated on amoxiclav, but he died after a week. This patient was treated and there was a relapse after two weeks. Statements like these point towards resistance, and natural language processing applications can help us to detect resistance from patients' information. It can review notes the same way, detect AMR patterns, and flag with early warning signs. So doctors, nurses managing patients on the wards, and they work with patients' notes day in, day out. These are bulky. They are human beings. They can't really take time to think through things well. But then if we have NLP applications, they can pick up resistance and say that, doctor, this patient has been on the ward for the past 2 weeks. He's not responding to XYZ. This pattern points towards a possible resistance, and then it can serve as an early warning sign for you to change. And by so doing, not only are you limiting resistance, but you are improving patient health. You are reducing the time they spend in hospital and improving outcomes. We can generate what we call antibiograms to guide clinical care. We shall see what an antibiogram is in a very little while. We can improve the diagnostic accuracy of medical laboratories using deep learning. CNNs, GANs, all these can detect or recognize images if well trained, and this can be extended to the laboratory. We will have a microscope, CNN-powered smart app on a phone. It can detect malaria parasites. Sometimes you come to the hospital, we draw your blood, we put on the slide. We scroll through the microscope up and down several times, and we may not see it, we may miss it. But the CNNs have greater accuracies, and they can at least augment our work. They can see things we may not see. So we can improve diagnostic accuracy using AI. We can monitor activities in communities. For example, some farmers notoriously feed poultry with antibiotics, in particular tetracycline, because they believe it makes them grow fat. And as a result of that, they breed resistance. Then the bacteria become resistant to tetracycline because we've used it so well, and the bacteria population has evolved mechanisms to escape its effectiveness. So when we have some smart cameras around monitoring the environment, they could pick some of these things, and then we could have that. We could also have cameras scan social media. A lot of chats, a lot of information now takes place on social media: Facebook, Instagram, YouTube, TikTok. So people will just be dancing merrily. Oh, she went to the hospital 2 weeks. They gave him amoxiclav. This drug doesn't work. Especially those of us who deal in the herbal area. Oh, yes, and here you may so 1 week we will call a well-trained LLP model can easily pick up bacterial resistance from these statements. So if we deploy NLPs in our social media context, they could help pick up antimicrobial resistance. AI can also help to fuse clinical and laboratory data to improve treatment. So now, as we have now, our data is usually in silos. You come to a health facility, the lab report is there, the doctor has his notes, scan notes are here, but we could have multimodal fusion. Just having some, even a large language model, WhatsApp can ask you, ChatGPT can ask you, bring the lab reports, bring the scan, bring the clinician's notes, and it will integrate them, detect hidden patterns, and then bring out more insights from it. Applications of AI in antimicrobial resistance management, I believe I've gone through all these from the little I've talked about so far. AI is important. It can be predictive, it can be transformative, it can be generative. You all know that. It can understand text, images, sound, process them just like the human brain, and can even work where data is limited thanks to generative AI. With the given data sets, we can have self-learning, semi-supervised learning, all that churn out more outputs. Now, just a brief overview of machine learning. So machine learning refers to those class of AI algorithms that can learn from historical data, observe patterns, and be able to make predictions. We all know, we are all familiar with all these, the k-means, naive bayes, decision trees, support vector machines, and all that. And we use them wonderfully in healthcare. We can deploy them in managing antimicrobial resistance. Now, let's just take a look at predictive modeling. So by predictive modeling, we are looking at a statistical technique whereby historical data can be used to forecast future outcomes or behaviors. It involves building mathematical models. So you have two variables. The variable share relationship, whereby one depends on another. This relationship can be modeled. You could have logistic regression expressing this relationship, especially for categorical or binary out variables. You could have linear regression if it's a continuous one. And we could build these models to model antibiotic resistance patterns. So a doctor in a clinic, you don't have a lab, but then you've observed that people are coming in with malaria, people are coming in with diarrhea, people are coming in with urinary tract infections. You have your pen, your paper, you've jotted this down, you've noted a trend. You've seen that people who have the fever for, let's say, 3 days tend to have this entity. You could plot this on a simple logistic regression curve, and you could obtain your line of best fit, and it becomes a predictor for you. You can always predict what kind of disease or outcome or organism most likely will be coming from that based on the pattern of the data you have. So these are ways we could harness AI to be able to mitigate the disease will go down. Decision tree algorithms, machine learning algorithms can be very useful in diagnosis and also in treatment. You have the root of the tree looking for some entity, and it branches and goes down based on the cutoff values and all that. So we can use this in TB diagnosis, as you've seen over here, and there are a lot on our hospital wards and all over. Now, deep learning, that subset of AI, you and I know, that was purely modeled on the architecture of the human brain. So basically, once upon a time, scientists sat down, they studied the neuron, inputs, outputs, the action potential, and they modeled it into the perceptron, which is the equivalent of the neuron in AI. And a group of perceptrons basically function just like the human brain in a syncytium. So the multi-layered perceptron we have down here, that's all what the brain does. So by way of this, it means our cameras can see as we see, our microphones can hear as we hear. We could employ deep learning to recognize objects in the laboratory, to include bacteria being tested, bacteria of various kinds, and various deep learning algorithms, CNNs, very, very good at image detection, if well trained, can recognize these patterns and can help extend these services there, especially in a part of the world where we lack laboratory scientists and we even lack the laboratories. If the doctor or the hospital can afford a microscope and there's a smart camera, it means we can be detecting some of these things early in remote areas, and all these measures contribute to reducing antimicrobial resistance. Natural language processing tool does very wonderful work with regards to statements and text. They can derive meanings, they can recognize patterns, they can understand context. So therefore, the notes, the information we have, for example, this is from a doctor's notes, a 3-day history of fever, rigors, chills. On examination, he was lethargic, warm to touch, and all that. We just subject this to the NLP pipeline. We identify various parts of it, segment them, tokenize them, and then at the end of the day, all these tokenized variables are fed to some neural network, the transformer usually, and then we are able to make a very good prediction that this information sums up to malaria. Similarly, if there was some pattern of resistance along this chain, the NLPs will be our best bets to be able to figure this out. So in this day and age where ChatGPT is readily available, there's no question of waiting to go to the lab or lab being absent. Doctors should simply upload these notes onto ChatGPT and resistance can be detected. As we can see over here, a doctor detecting resistance from notes just by reading the NLP going through the statements, and patient is not responding to this drug. We've already picked up resistance. So these are ways in which AI can help to mitigate resistance. Social media, we've already talked about this. NLP can observe trends in social media analysis, clacking notes, chatbots, etc., and pick up resistance very early. Now let's try and understand what antibiograms are so that we'll appreciate it when I begin to discuss how we can use our machine learning models to handle these issues. So an antibiogram is a report generated by a lab that summarizes the susceptibility of bacteria to various antibiotics. It helps clinicians choose the most appropriate antibiotic for a disease. So what they do is someone comes, he's sick, we draw the blood, we take it to the lab. They are able to grow the organism. Maybe it is salmonella, maybe it's staphylococcus, and then we are able to test the organism to a range of antibiotics. Maybe we give it some amoxiclav, some cefuroxime, some metronidazole, and then we notice that there's some zone of inhibition on the plate, which shows the ability of the antibiotic to kill the microorganisms. So we aggregate this data and then we plot it in the form of a table. And that table is what we call an antibiogram, what we have over here. So an antibiogram displays organisms and then antibiotics they are susceptible to or resistant to based on the lab tests that we've done. Right, so what it then means is if the doctor or prescriber wants to prescribe, he has to consult or refer to the antibiogram and then see which drug is most susceptible to that organism. Then he prescribes it. That is what we call rational use of antibiotics. The antibiotic choice was based on reasoning from this data set. Exactly. But the challenge we have over here is that we don't have enough of these labs. And even the few areas that the labs are, people can't afford it. For instance, to do a blood culture, you have to pay close to 500 Ghana cedis, sometimes even more. A lot of people who are critically ill are not being able to afford it. And one innovative way to go about this is to turn around the curve. So instead of looking for disease and organism, we could also look at the blind choices you made and the outcomes of treatment. So that if people came, you don't know the organism, you gave drug A, but you observed a success, then you could plot these down so that when people come with similar presentations, you could proffer that drug out. So with machine learning algorithms in place, which are very good at handling structured data like tabular data and all these two-way interrelationships. We can do a lot with AI to help the situation. So the challenge here is lack of data-driven antibiotic prescription, from what I've said, due to logistic, technical, and economic constraints. And the innovation is that data from empirical treatment outcomes, treatment that was done for patients without labs, can be used to improvise this antibiogram in resource-constrained areas like us, and we can use predictive modeling algorithms to be able to make meaningful prescriptions. Okay, so on this premise, I propose this innovation, BioSage. So BioSage is supposed to be an AI-powered antibiogram system which should operate without lab data. Basically, we should have algorithms that can learn from empirical treatment and outcomes to support rural clinics and places that are underserved with smart devices. So this is a sample homepage screen of how the BioSage should look. And with this, the doctor has the BioSage in his arms or in his palm on a device. He or she should be able to input data on the patient, his name, age, the duration of symptoms, the outcome of treatment, the antibiotic of choice, and the algorithm should be able to build the antibiogram for him. So a sample page over here, you input the patient's information, your drug of choice, your outcome of treatment, and then the algorithm does that. Let's try and see some of the computational methodologies underpinning some of these machine learning algorithms we could use. We could make use of simple linear logistic regression models. Logistic regression models mainly per se for here, for this instance, because the variables we are dealing with are categorical. Antibiotic type, outcome of treatment, whether it was a failure or a success. We could also make use of deep learning. Various deep learning algorithms will suffice in here. We could make use of Bayesian networks, which make room for things like missing values and handling missing values, and then also being able to adjust for confounders, because this improvised thing here would have some confounders. For example, it means we are basing our decisions based on blind treatment. The person came with fever, we gave chloroquine, and then he responded. It doesn't necessarily mean that the chloroquine killed the organism. It could be that it was another disease altogether that went on its own. It could be that the, we didn't diagnose the thing well, but all these things have not been captured. We just went in blindly, we gave this and it went. So we should be able to adjust for confounders for this antibiograms to work, and Bayesian networks readily allow for that. So basically, to run through the computational methodology, we have an empirical treatment database, which we've gathered, let's say, assuming we are all prescribers or doctors and we've met patients, we've gathered our database. Then we go through the pre-processing stages. We clean the variables, impute missing variables, extract features for training the model. Then we decide on a machine learning model. Maybe we want to do a logistic regression model. We build it. Then we apply sharp values. So sharp values sort of attach some degree of confidence to the outcomes, so that when you say that this person with a fever and this presentation looks like malaria and warrants chloroquine, the sharp value will say, well, looking at the values you have over there compared to a real world scenario, you are speaking with, let's say, a 90% degree of confidence. So it sort of does a confidence scoring for the model to be applied in real world. And then the pre-processed data model also is able to predict the antibiotic susceptibility, which is looped to the sharp values to further refine the confidence. So at the end of the day, with the given information, we compare it to the real susceptibility of the organism to the antibiotic, like it will be in a real world, to see whether there is too much difference. In other words, we think it is salmonella and you have to give Cipro. In the real world, looking at how things are, is that the case in maybe about 90% of the time, or maybe it's just the case in about 30% of the time? If it's in the case of about 30% of the time, then it means obviously we are making a wild guess. So that's what the loop mechanism together with the sharp values tend to do to help with the model. So a completed antibiogram typically will look something like this, where we have our drugs at on the as columns, and then diseases as rows, and we'll be able to make our predicted resistance levels based on the machine learning model that we generate as low, intermediate, or high. Okay. Other intelligent technologies exist for this. These include whole genome sequencing, and our colleagues who do bioinformatics do encounter a lot of these genome sequencing algorithms, which can also be used to trace resistance. So then we can predict resistance by analyzing genomes, large volumes of genomes, and we can tell specific genes that can be responsible for this. We could make use of mobile health and SMS alerts. So even in resource-constrained areas where we rely more on these YAM phones and things, simple SMS texting can play a role in education. They can play a role in awareness creation, assuming COVID should just come out as it's done now at Legon over here. In a village, we could send a message round through bulk texting to people, and then they could recognize these things. Smart devices over here to include things like the smartwatch here can detect subtle changes in temperature and pulse, which could be very, very good anecdotal markers for sepsis and for infection outbreaks. So these things will help to detect infections early, and they all help to cumulate to reduce resistance. We can also integrate our decision support systems with AI. So currently in our hospitals, we have the LIMS and the DIMS. If we bring AI on board, these machine learning algorithms, like we've said, can sift through patient data. NLPs can pick up resistance. CNNs can detect diseases early from images and all that, and they can help to curb the phenomenon of antibiotic resistance. So benefits for Ghana. Ghana stands to overcome diagnostic infrastructure gaps. These apps too will support rational prescribing in low resource settings like we've seen, and it can be scalable to health centers, CHIP zones. CHIP zone, for those of us who don't know CHIP zones, CHIP stands for Community Health-Based Planning and Services. Basically, in the very, very remote villages, we have this small system whereby, because they don't have doctors, they may have a community health nurse, one or two health workers there. They do treatment of minor ailments. Some of them even do deliveries of babies, vaginal deliveries, not the theater type. We call them CHIP zones. So because they lack access to clinicians, they can fall on some of these AI-based mechanisms to at least guide them to prescribe the right antibiotics for the patients when they have access to this. The challenge is data quality and interoperability, bias in model training, which we can overcome if we select our samples to be well representative, if we also use various techniques, the smooth adacil, all the things we learned in for balancing data sets to train appropriate models. If we select appropriate models based on what we want to do, we can also limit bias. There is a need for local validation. So we need more health practitioners to study AI so that they can be able to understand and appreciate how these algorithms work, and then their outputs. So the way forward for Ghana is to establish a digital stewardship infrastructure to promote AI and then antimicrobial research via institutions, UGMS, Noguchi, Kolebu Teaching Hospital, etc., to pilot these things and to create a national innovation hub. So our final thoughts: AI is not a luxury. It's a strategic necessity if you want to win the war against antimicrobial resistance. So with this, I bring my presentation to an end. Thank you all.
Thank you so much for your presentation. I have a
Thank
lot of
you,
things
sir.
on my mind, but we have panelists who are going to, determine who goes home with some amount of money, among other things. So we'll give preference to our panelists and any other person, of course.
Yes, sir.
When you're all done, I'll ask mine.
Yeah, thank you, Bramak.
Thank you, sir.
Thank you for the presentation.
Yes, sir.
Yeah, with regards to the antimicrobial resistance issue,
yes, sir.
And as a result of this, many lives are lost. In Ghana, there is a notion among the citizens that most of the hospitals do not have a robust laboratory equipment for effective and efficient diagnosis. So you go to hospital A, the problem will never be realized there, yet drugs will be administered to keep the situation. You go to B, they will tell you something slightly, but not as a whole. A medicine is prescribed. And you will now go to another one, they will now see the real problem.
Yeah.
How do you correlate these three phenomena to the antimicrobial resistance menace?
Exactly. Okay. Thank you, sir. So, like you rightly said, sir, this thing happens. People hop from institution to institution. They don't get solutions to their problems, and they keep going. So, one way in which, first of all, AI can help is to detect the trend and the pattern. So, he went to hospital A, was given amoxicillin, didn't improve. Went to hospital B, was given maybe crystalline penicillin, didn't improve. Went to hospital C. Definitely there's some resistance of the sort against penicillins. But human beings being in our haste and then also our inability to handle various situations so well might miss this. So we might just conclude that, well, the drugs they gave here, they didn't work. Let's try something different without really thinking through. But when we have NLPs analyzing doctors' notes, they could pick these things up readily. The second challenge is that for our health care, so in a lot of the health hospitals, they just sit within the confines of the hospital. So you hop from, let's say, Nyaho to Leicester. Leicester can't know what Nyaho did. Nyaho can't know what Leicester did. Even within the government sector spheres, if you go from, let's say, Kaneshi Polyclinic to Kolebu or Mamobi Polyclinic, they can't tell what was done here. So then it becomes difficult to pick these things up. But if they were well networked, we could have been able to, at least the doctor will read what was done here, try and juxtapose it to this one. And more so if the AI was there, if we had some NLP support for these things, it could readily generate a summary and it will highlight certain features that these trends have gone through all the three places the patient has visited and will be very helpful in management of the results. Sir, please, have I helped with your question? Thank you, sir. Yes, please.
Yes, so, do I have your permission?
Yeah, please, go ahead.
Just a small point.
Yes, sir.
Talking from one hospital to the other. So my concern is the herbalist.
Yes, please.
The herbalist. So
Yes.
where do they also place in this your
In this,
interesting
yes,
study?
right.
Then the other homeopathic, there's now a plethora of medical
alternative
services.
medicine
Yes,
people.
alternative medicine and all that.
Yes, exactly. So they don't deal with the conventional antibiotics and antimicrobials we use. They have their own system of medicine. For instance, some of the herbalists do plant-based medicines. A lot of the antibiotics are from plants, but they specifically call them plant-based because they have some class of plants they deal with, which are not in the orthodox system. Now, these drugs may work, but if they work, they will be susceptible to these same phenomena. Resistance actually is a function of evolution. So just like human beings, we evolved to escape trouble. So the very primitive humans were walking barefooted. Then they realized they were getting injuries. So then shoes came to being. So the same way to the organisms to evolve. Evolution is necessary for survival. So the bacteria realized that the chloroquine is killing them. Then they develop special receptors, some of which will knock out the chloroquine when it hits them. So they also develop mechanisms to evade that. So in the same way too, with the herbalists, with their class of drugs they use, the organisms have resistance against them. So far as they are biological entities. So bees, maybe they say go and drink neem tree leaf that has been grounded, or grind some grass and use whatever active ingredients that are there in it that attacks these organisms. With time, the organisms will learn to sway against them. So it is a phenomenon they also battle with in their space.
Okay, you also have a question.
So my question is a follow-up to what my colleague asked.
Yes, please.
And let's consider a scenario where a patient combines the alternative medicines and what we might call orthodox medicine.
Orthodox medicine, yes.
In that instance, how does the algorithm come in to determine the correlation between the two?
Between the two.
Yeah.
Yes, please. So basically, our algorithms are trained to manage the relationship between variables. So the various variables in question must be defined. So for example, if you are looking at the alternative medicine setup, or if you are looking at the herbal setup, for instance, they have a class of drugs they use. That is one set of variables. And then they also have outcomes with the patients. That is also another set of variables. So maybe neem tree causes failure in some people with fever, or maybe cassava roots causes cure to, let's say, cancer or fever or diabetes or something. These are the variables. So once the algorithm gets the trend of these variables, to be in a position to make predictions. Say, please, have I helped with your question? So lost. Yes. So the variables should be clearly defined, whether it is alternative medicine or orthodox medicine. The concept is the same.
I was trying to find out in the instance of the doctor who is using your application.
The application, the antibiogram.
Yes. To help the patient.
Yes.
And the patient is on both the prescriptions given by the doctor.
The doctor. Okay.
And some alternative
Medicine.
How do we marry the two?
Marry the two. Okay. So with the doctor's own, if the doctor use the antibiogram to prescribe the thing, for it to guide him to do it, he will do it very accurately because he has used patterns from learned outcomes. He will make a good choice and do that. If the herbalist also followed the same approach, that is, if the herbalist has been keeping an antibiogram, well, we have medically trained herbalists who actually are permitted to practice in a lot of the hospitals. Those ones, I think they are a bit organized in their work, but the traditional ones on the ground, a lot of them don't really have any formal training, and they don't really quantify their work. So for example, you might visit them and they'll tell you, go and drink neem tree. Whether you have to drink a spoon or a cup is not really defined. So you might just go and prepare a big pot of neem tree and just be drinking anyhow with its associated toxicities and all that. That's how the local herbalists do. But then the hospital-based ones, they also work in a similar fashion. So they have their resistance trends, and then they can actually follow this data and make that prescription. So with the given scenario you talked about, if the patient visited the doctor in the hospital and the doctor uses the antibiogram, he'll get a good response from it. If he visits the medically trained herbalist who uses a similar way of working, actually the antibiogram is just an extension of, I would say, what we always do. The normal thing you do is when you have a fever, the first thing that comes to your mind, let me take para because para works for fever. let me take brufen because it works for fever. Just that we've extended it to include a large data set so that the AI, the machine learning algorithm can make a very robust prediction. So that is the only difference. But it's a normal day-to-day thing that we all do, just that we don't call it an antibiogram. Exactly. So these things exist in lay practice. But for the people, the herbalists on the street, for them, I can't speak for them because their ways are quite unconventional. And so they, first of all, they don't use a scientific approach to arrive at their conclusions. They'll just tell you, oh, you have cocoa. What the cocoa means doesn't even stand out well. The cocoa could be a rash, it could be hemorrhoids, it could be anything, but they call it cocoa. And then secondly, when it comes to treatment too, they have their own way of treating. They've empirically observed the environment and they realize that maybe hibiscus can deal with vomiting or neem tree can deal with this. And they don't apply any logical way to quantify it. So with this, it becomes difficult working with their class of data. But then if the patient has been through these two, we can, yes.
Yes.
Yes,
are all the questions done? I have quite a lot. Maybe I may veer more into the academic aspect of things because I'll be frank, I feel like this is the presentation has been like on a platform where you are discussing the essentials of AI in the particular domain.
Yes.
As far as our domain is pretty much concerned, we would have been I would have been expecting some literature backing some of the assertions you are making. For example, in the lay practice, this is what is happening. These people published it. And so it is supporting what is going on. You largely spoke about AI. NLP can pick what they have, the information that has been provided, and it's for translating to stuff like that. The nitty-gritty of these, what model are you referring to? What does the existing literature say about the models that are being utilized? And what additions or changes do you think you're going to make to them? And then, I mean, it's like more general presentation you've made to us. Final thoughts, AI is not a luxury. Yes, I understand. But technically speaking, and academic from the academic perspective of things, I wish to appreciate what literature is saying and what you intend to do. You know, there's been clarity in some of the presentations. It's a systematic review, you have your expectations. If it is an experiment, you will have your expectations. I am struggling to really position this in any of these concepts so that I can really ask questions. If you had gone deeper into NLP, I will have more questions. Computer vision might not, but I mean, I want to really appreciate these things. I believe that's where your novelty really sits, your contribution really sits. You know, then by extension, your solution can support us in a lot of ways. But in this academic circle, please appeal to me if there's anything you can point at. If you didn't venture there, that is also fine, but I wish to know.
Okay, so I didn't venture too deep into the algorithms, particularly the deep learning algorithms, because of time and complexity.
So then how were you convinced that AI can do that?
We use them. These are readily usable. ChatGPT is readily available. It analyzes these notes from time to time.
So has anybody used ChatGPT by way of literature to achieve something that you have done, which you didn't probably mention? I don't get the angle I'm coming from.
I get
Here we don't speak generically. Maybe I saw online ChatGPT because you are using it. This is what I think. It's pretty much more of empirical evidence. You read, you reference. Statistics say this. So that premise, I don't think is sitting well with me. So that's why I'm even from that angle. Is it your usage of ChatGPT, or you've seen some people using it? Who are those?
Yes, please. So please, I get you. So with ChatGPT, for instance, there are a number of studies out there that have outlined its role in clinical decision support. Various people have used it for diagnostic purposes by analyzing images, analyzing doctors' notes, and other things. Its sensitivity and all those evaluation methods.
But you can't reference any of them right now.
Yes, because of the nature which which the thing went. So I didn't want to extend it too much to.
Well, but my little advice, we are all students, but my little advice would be that if you have a huge panel, academicians, if you have observed what has been going on,
yes, sir.
It is not about what we feel. It might be substantiated. You even made mention of empirical something, but then I was hoping that you make a reference. So and so conduct empirical evidence, and they realize that lay people of this percentage are doing this and that. That never showcased in your entire presentation. So it is like a motivational speak to let us an advocacy for AI in your domain, not more like a research presentation for my MSc. This is how, if I don't know about others, but this is
yes, sir. So,
my
this is not my MSc project. It's just a presentation. I mean.
Oh, okay. He wants to dig. Okay, fine. So bear with me on that. So, any more questions from anybody else? All right, time is running out against us. You want to ask him a question?
Yes, sir.
Yeah, okay. We'll take that question. In any case, the fruits are ready. We are interlacing the break with the events. Yeah. So you might want to pick something before Mr. Aban will make his presentation. We'll take some remarks from some special guests who have joined us online. So please take notes. We have somebody from Central University and another people. Will take remarks from them. You meet him later to ask your question. Okay. All right. So on that note, I don't think I've seen anybody raising their hand online.
Yes.
There's hands online. Please, let's hear you. Please go ahead. Yes. Oh, Dr. Brown, one of the panelists. Please go ahead and make your comments, please.
Thank you very much for the opportunity. I would like to say that this presentation was a good one. In fact, I couldn't join early, so maybe you should pardon me when I asked the question and you actually spoke about it earlier. I would want to know what your data set actually, or where you would get your data set. Or how you intend to get the data set for training your module. Also, I overheard you talk about the ChatGPT, the use of ChatGPT in making for diagnostics. Or were you saying for diagnostics or making some clinical decisions? I cannot hear you, but
hello, sir. Sir, please, can I be heard now?
Yes.
Okay,
yes,
so
clearly.
To the first question, so we'll get the data for the data sets to train the model from the clinics. For example, we could pilot a clinic. We just have data covering doctor's choice of antibiotic and patient outcome. So someone comes in with a fever. We chose Cipro or ciprofloxacin. What was the outcome? Did it cure him? Did he die? Did the disease relapse? So we do that over some time. Let's say 6 months. We aggregate, let's say, 1,000 cases. Then we use it to build the model, maybe a logistic regression model as to antibiotic choice being the predictor, and then the outcome being treatment or failure. That is an example, sir. And then to your second question, the ChatGPT, yes, we use it in diagnostics, both imaging wise and text wise. So it has a feature that allows us to upload images or pictures. So you could upload, let's say, an X-ray, a blood film comment, a CT scan on it, and it will analyze it and produce the results. Also with text, clinical data like doctor's notes on the ward too, its natural language processing mechanism makes it understand everything, the context, the statements, and then predicts the right answers, which we use. But I must caution that it must be used with human oversight, since it has a tendency to hallucinate.
Okay, so I'm glad you mentioned the hallucination part of it. However, one problem you are going to face in collecting this data set is that most of the data we have at the clinics are not structured.
Yes, sir.
So it will be really difficult for you to put them in a structured manner.
Form. Yes.
There is yet another problem you may face. Merely saying that this drug has been given and there is this outcome is very difficult to ascertain at the clinic level.
Yes,
it's difficult because you give someone paracetamol or chloroquine today, he may not turn up, you will not know what the follow-up or the feedback may even be. So the data is not complete. The data you have there are not complete. Secondly, when you talk about ChatGPT, using ChatGPT for clinical issue is very, very, very which word do I use? But it's very troublesome, for want of a better word. Being that, who will be responsible if ChatGPT goes wrong? And this is a crucial and a critical domain you are looking at. One mistake may kill a lot of people. So you would rather want to explore the use of knowledge base, okay, a reliable knowledge base, and then use that knowledge base to train a model, okay, to train a model in a given domain.
Yes, sir.
Like maybe malaria detection or malaria diagnostics and all that. So you can do that for different diseases, okay, and then you can say that indeed these models are able to do for this particular disease. But then looking at it from the point of ChatGPT, you will be killing people if you go that direction.
That way. Exactly.
Yeah.
Sir.
I will include a few comments in the what are the score sheets, and you may want to attend to them.
Yes, sir. Yes, sir. Okay. So thank you, sir. Sir, like you rightly said, sir, please can you hear me?
Clearly.
Okay. Yes, sir. Sir, please, so like you rightly said, first of all, the notes in the clinical arena are not well structured. So I thought of a few data warehousing techniques that we can use to structure unstructured data to kind of make them in that way. Another way too is to, for the purposes of the trial, perhaps we could provide a format so that the doctors feel it in that structured way we want while we do the study. This means I thought could help with that. The second phase of your questions too looked at the problem of loss to follow and missing values. And these are very true, and these are confounding factors to the study. And there were some algorithms to, like Bayesian networks, for instance, that could allow for one to adjust for the confounding factors and to impute missing values. So we could leverage on some of these algorithms to handle some of these situations. I'm thinking the whole idea is not to produce a perfect score out there, but at least it will provide a good guide for the doctor, so that as opposed to just making the decision to prescribe out of mere will or casual observation, at least there's a trend that can inform something. So I think if we employ some of these algorithms, they can help to some extent to with this one too. And then the third aspect to the ChatGPT, so I perfectly agree that its associated issues of hallucinations can be misleading. It being largely a probabilistic model is subject to a lot of randomness and uncertainty in its output. So if we fall more on the knowledge-based or the rule-based systems, we are likely to make more well-defined decisions and diagnosis, and we can use that to train our models in the in little areas too, in the clinical areas. So sir, please, I perfectly agree and appreciate all the contributions. Okay, Thank you so much.
Thank you too.
Dr. Clifford wants to make a comment as well, but again, in your submission, if you looked into literature, you fine-tune a lot of these things, pin them down. Which algorithms? Bayesian is broad. Like at this level, is very broad. When literature will inform them, we will not make uninformed assumptions, in my opinion. Anyway, I'll hand you over to Dr. Clifford Bruni to ask his question.
Hello, Dr. Clifford. Sir, please, we can hear you. Kindly speak.
Okay, thank you. Actually, some concern I first had, Mark talk about it like, and you address it that it's not your actual, it's just like kind of opinionistic presentation, which is a bigger picture. But I just want to say something about the data. The data aspect that with regard to it being structured or not structured. I just, because you want to do this work, so I just want to make a comment about the data in case you want to handle this work.
Yes, sir.
You said that within the field of medical data, it can be a scan document, it can be a text document, or it can be an image.
Yes,
all
sir.
this data, like you said, is unstructured data.
Yes, sir.
From my point, either you are using vision language model. In that case, that model will handle both the image and the text. Even if it's a scan copy, at that time when you scan, it become an image. And all these models handle unstructured data. So from my perspective, you don't have anything to worry about the data being unstructured. Because LLM handle text data is unstructured data. And so that's why we do tokenizer. You token the data before you pass it through the model. So from my perspective, the data being unstructured is not anything that you need to build a data warehouse, whatever that you were trying to propose. I understand that you are now within the field. So that's why maybe you were not able to maybe articulate what you intend to do. So the point I'm making is, being LLM, if you are using pure text model, which is LLM or sentence model, the data they handle is unstructured data. Okay. If you are talking of vision data is unstructured data. So these models just deal with unstructured data. So don't worry much about the data. The only thing is you should just, for your MSc, narrow the field and handle it. Then after the MSc, if you are in the medicine, if you want to build a big package and make it a business, that's so big. But I just want you to be assured that don't worry about the unstructured data, because that's what vision language model handles, and that's what LLMs handles. So you are good to go. Just read much about it and you can get it done.
Yes, sir. Sir, thank you.
Yeah. So we thank you all. We'll discharge him. I think he's done a good job. Thank you so much.
Thank you all.
Yes. So at this juncture, we'll take a few remarks. Again, a round of applause for him. Yes. He's done marvelously well. Right. We have a couple more people. The acting dean of School of Technology, if I'm getting the name correct, at Central University. Before Mr. Aban joins us on stage, I think he's getting ready to set himself up. We'll take a few remarks from them. You know, they've spiced this event up with their presence and their participation. We are really, blessed. So Dr. Nana Bajan, Acting Dean, School of Engineering and Technology, Central University. Ladies and gentlemen, let's give him a round of applause as he gives us a remark.
Yes. Hello. Good afternoon. I hope I can be heard by everyone. Okay, great. I have thoroughly enjoyed being a part of this since morning, from the very first presentation. I got to know even from that this has been going on for the past 3 days also. But this is the first time I am joining, and I have been thoroughly satisfied with what has happened. I'm happy that the School of the Computer Science of Legon is championing this. Also making it a first for UG itself. That is something exciting. It shows how technology and computing especially can lead the way in many areas as this. The world is moving very fast and we cannot pretend not to recognize what is happening elsewhere and sit back and not do anything. So to the organizers, I'm very happy that you did this. You've certainly set the pace for some of these discussions, and I'll be always available to join further such events. Thank you all very much.
Muted. Sorry about that. Those of you online, I'm taking that again. Yes, Mr. Dr. Edward Kofi Sutherland. I'm sure you can hear me. I can see you right there. We are grateful to have you. You give us a few remarks. Again, like I said, he's a medical director and faculty Ensign Global University, site director, West Africa Center for Global Surgery, University of Utah. We'll take your remarks, please.
Thank you very much, sir. Thank you very much for the opportunity. Do you hear me?
Yes, we can hear you.
Do you hear me? Okay, sure. Thank you very much for the opportunity to observe this workshop. As already mentioned, I have a medical background, a public health background, and also an implementation science background, and I have great interest in IT. And so observing this workshop, which has been put together by the Department of Computer Science, University of Ghana, has been very exciting for me, as I can already see the potential of the things that need to be done in the areas of health. Just as a way of highlight, public health, where I am actually working in, is the science and art of preventing disease, prolonging life, and promoting health through the organized and informed choices of society. And so I actually see the potential and collaborative initiatives that IT can bring to the field of public health. And I want to echo the statement by the last presenter. I actually think that he made a very strong statement saying that AI is not a luxury, but it is a strategic necessity. Once again, I want to commend the Department of Computer Science at UG, and I want to congratulate all the participants for their brainstorming, their thoughts. It has been really exciting. Thank you.
Great, awesome. Right, we are grateful for gracing this event with your remarks. We really appreciate this. So we've had people speaking to us from Australia, Japan, and now the US. I think we've gone far. And Canada, yes, there was Canada too. Please, let's give ourselves a round of applause. Your participation has also added some bit of color to this event. Mr. Aban will join me up here and proceed with his presentation. Again, we have some fruits out there for those of us in-house. Let them not go waste. You can pick some and then have a good time. So, yes, I think he's already sharing his screen, so we'll just hit the ground running. Ladies and gentlemen, Mr. Federman is a PhD student, and he has a presentation for us on this august occasion. The floor is all yours.
Good afternoon. My name is Frederick Aban, and I'm a PhD candidate at the Department of Computer Science, University of Ghana. We are researching on self-interference cancellation. Sorry, I'm being supervised by Professor Jamaldeen Abdullahi. He's my lead supervisor, and the other supervisors are Professor Katriku and Professor Solomon Mensah. My key research area has to do with self-interference cancellation in full duplex communication systems. But today I'll be presenting on a secured arguing mode and learning-based detection algorithm for eavesdropping and intrusion detection in full duplex MIMO systems. The question that you may be asking, or we are asking ourselves, which was asked by my lead supervisor in our early days, is why the need to move from 4G to 5G and from 5G to 6G, and possibly we might be going to 7G and 8G and whatever G in the future. Why don't we just remain where we are and improve on what we have? What we've noticed is that there's been exponential growth in data traffic, exponential growth in wireless subscriber users globally. And the growth rate is so high that the technology every 10 years is not able to sustain because we are not making good use of the spectrum available to us. Now, if you check the image I have on the screen, this is for subscribers, and they are in billions. Between 2025, which is approximately 15 billion subscribers, and then year 2030, we'll be looking around close to 21 billion subscribers. Human beings on Earth are not up to that much, but we've got enough devices to go over the population of the human population. Traffic-wise, between 2020 and 2025, we grew from around 62 exabytes to around 607 exabytes. But between 2025 to around 2030, we'll be increasing to over 5,000 exabytes, which is so many others high. But we are still practicing the same technology. So researchers have started looking at better ways of improving the technology we have. Currently, what we do is called half duplex. And so for us to transmit and receive, we use two channels, one for transmitting, one for receiving. And that is actually a waste of resources. And so we are looking at full duplex, where transmission and receiving will be done using one channel, so that we can maximize the resources available to mankind. Now, let me use these images to explain half duplex and full duplex. The first image to the top left has got a base station and a mobile station. And for communication to take place, one channel is used to transmit. Here I'm using the red for transmission and the blue for reception. And another channel is used for reception. That's two channels. In the case of full duplex, using the image to our extreme right, transmission and reception are done using one channel. And so the two channel, we can double whatever data volume that we want to communicate. However, full duplex come with some challenges. And those are the challenges that we are addressing in the Jamaldeen lab. One of the challenges is called self-interference. And this is what happens in self-interference. Self-interference is a transmitter. Say this transmitter would want to communicate with a receiver, a mobile station. So the base station transmits, and the receiver of your mobile device is to receive that communication. But when the signal is transmitted, the receiver of the same base station also receives the signal. So it's like you are talking and you are hearing yourself. Now, when the mobile station transmits to the base station, because the power of the mobile station is not high enough compared to that of the base station, the self-interference at the base station distorts the signal coming from the mobile station. For that reason, communication does not go on very well. So we are looking for ways of canceling the self-interference, and that is the key work we are working on. But apart from that, there are other challenges also in full duplex communication. Now, these challenges include, I've already mentioned self-interference. Then we have eavesdropping. We also have active and passive intrusions taking place in full duplex communication. Jamming attacks. We have channel state interference feedback attacks. And then signal leakages from multi-antenna arrays. So these are some of the challenges that full duplex communication faces. In this research, this particular research I'm presenting, we are looking at the intrusion activities as well as eavesdropping. And we've developed an algorithm to be able to identify the intrusions and eavesdropping in full duplex communication. I had to reduce my slides because I noticed time had fast spent, so I just modified it so I'll go a little faster. So we have developed a framework for intrusion and eavesdropping detection in full duplex communication. And what we looked at, or the block of the framework, is made up of channel observation and modeling. We are looking at eigenmode decomposition. We are looking at variance-based anomaly detections, secrecy rate optimization, and then we inject artificial noise to deal with the intrusion, and then to also make sure that at the end of the day, the signal that will be transmitted is as accurate as what initially came in. And then we do multi-objective power and beamforming control. I would explain the first part, which is the channel modeling, and then I will show us a pseudocode, and then afterwards, I will go into a live demonstration of our algorithm, and then you can bring your inputs, and we can make modification and see kind of result that we will get using doing a live demonstration. So, the Y above is a received signal being transmitted to a particular receiver. Now, a signal being transmitted is actually made up of the desired signal or the desired channel, the self-interference channel, and noise. And that should have been the end of the story. Gaussian noise, as in equation 2. That should have been the best optimal way. So equation 2 should have been a legitimate signal with desired signal, self-interference, and noise. However, in the instances where there are eavesdropping, the eavesdropping is added to the transmitted signal or the received signal. And so we have our intention or what we worked on was identifying the eavesdropping signal and then reporting them same. But this is not just simple values. The desired signal, the self-interference signal, the eavesdropping signal, they are complex values. And so we cannot just do elimination and take them off. If they were simple values, we could have just used elimination and then we could have eliminated them. But they are not simple values, and so we require additional computation to take care of the eavesdropping signal. The equation 3 here tells us how the eavesdropping signal is. So the eavesdropping signal has got, the received eavesdropping signal is the eavesdropping channel plus an eavesdropping noise. And that is equation 3 over there. Now, this is how a typical signal looks like in a matrix form. So a typical signal has got an ith and a jth complex values, like I said earlier on. And these complex values would include amplitude attenuation and phase shift and other features. And when you take an example, the H21, the H21 refers to the channel of base station of transmitter 2 communicating with of antenna 2 communicating with antenna 1. So that is that. So that is how, and the H11 is antenna 1 communicating with antenna 1, and so it continues like that. And like I said earlier on, these are complex values, and these complex values comprises of the receiver signals and the transmitter signals. So in a pseudo form, what we did was we observed the received signal, the self-interference signal, and the transmit power. Then we decomposed the observed signal using SVD. Then we computed the variance of the signals and the power, and we also computed the eigenvalue of the variance, or the eigenvalue variance, and then we compared the variance and the threshold. And so if the variance was greater than the threshold, it should flag that there is an intrusion or eavesdropping. And then we also checked, or we computed for the legitimate secrecy rate and the eavesdropping secrecy rate. And then we optimized the transmit power. After that, we injected an artificial noise. Like I said earlier, the intention of the artificial noise is to help us recompose the decomposed signal. And then when that is done, the recomposed signal with artificial noise is then transmitted. We then pass everything we've done through random forest training for future predictions, so that we can learn and be able to predict intrusions and eavesdropping. And then we did evaluation of our results. Now, the area under curve, which is the AUV, our intention was to get values greater than 0.9. 1 is perfect, but we were expecting to get 0.9 and above. And when we go into the simulation, you will see what we did, how we got the 0.9 and above, and where we got 1, and where we got by far less. We will just try them here ourselves and see how we went about it. So these are the parameters we use, the base parameters, and we will amend them in the course of our implementation. So we did a simulation in MATLAB using full duplex MIMO system simulators in MATLAB. We assumed our initial transmitter, our initial number of antennas for transmission to be 8, and initial number of antennas for receiving to be 8 also. We assumed that there are 4 nodes for eavesdropping. We used 1,000 Monte Carlos for our iterations. And then, like I said, we did a random forest classification, and we used 100 trees to get optimal results. Now, let us go to this. So, for finding our result, this is the table that explains the various outputs and what they mean. So, if we get 1.0, it means it's perfect classifier. Between 0.91 and 0.99, it's excellent discrimination ability, which is what we're actually looking for. Anything above from 9.91 and above is something that we're interested in. And then it goes down, down, down. But I want us to look at 0.5 and less than 0.5. So when you have 0.5, then there's no discrimination. And less than 0.5 is worse than random. And those are areas we did not want to go to. So now, the slides are not from here, they don't look very visible, but I'll try and explain. So the first image, which is A, we use 8 transmitters, 8 receivers, and 4 eavesdropping nodes. And what we got was 9.9 something. I can't see. There is something covering my screen over here, so I'm not able to see the figures very well. I should have put them 2, 2, 2, 2, 2.
On Zoom is very clear for us.
On Zoom it's very clear.
Yes.
Oh, very well. Then it is here that it's not very clear. So when you check scenario A, B, C, and D, they all performed very well, being in the 0.91 and 0.99, A, B, C, D. Now, the numbers beneath them tells us how many transmitters and how many receivers, where 8 by 8 by 4 is 8 transmitters, 8 receivers, and 4 eavesdropper nodes. And 16 by 16 by 4, we also did the same 16 transmitters. Because we are working in MIMO space, we change the number of transmitters and receiving for multiple inputs and multiple outputs. Now, they all performed very well, falling between 0.91 and 0.99. However, when you get to scenario E, which has got 8 transmitters, 8 receivers, and 16 eavesdropper nodes, we get 1, which is the perfect condition. We got 1, which is the perfect condition, 1.0. And when we went, and I'll be coming there, when we went to 8 transmitters, 8 receivers, 4 eavesdropper nodes, just like the scenario A. However, with 50 trees, we went beneath the 0.5 threshold, which is not good at all. So we noticed that when we have more random forest trees, it performs better. So we also noticed that we had a very high true positive rate for the leakage detection. We did 1,000 iterations, and all the 1,000 iterations performed very well between the eavesdropper. We were able to identify the eavesdropping, and we were able to identify the intrusion or the security side. And we had little or no or very low false positive. Let me be quick to add. I ran the iterations or the simulations severally. In the very instances, some failed. And the more we ran and trained, it started performing better. And so we didn't get this result from just one try. We had to iterate them severally before it started picking everything perfectly. And so our security rates performed very well. Our maximum eigen mode, minimum eigen mode were as we expected. Now, we then did something which is very futuristic. We are assuming a future where we can have about 1,024 transmitters and receivers, which is, we are not yet there. And so it is called in the literature extreme massive MIMO. That is what it's called. So this is a scenario in the future where we expect to have a very huge number of antenna arrays. What we noticed was the time for the computational time increased significantly. For all the previous one, the computational time were microseconds. But when we went to about 1,024 antennas for transmission for receiving, our computational time exceeded 3 minutes, which we have to go back and identify how we can improve on. And so if those of you online might see it better, but over here I have 1,024 transmitters and 1,024 receivers, just like I said earlier on, just to move into the futuristic zone. But the good thing is that it performed at 0.96, which is also quite good. We also ran some algorithm changing our iterations from 1,000 to, say, 10,000, and to see how it performed. And in all instances, they did perform quite well. So I would move from here and then switch to the MATLAB codes for us to run some simulations, just a few of them, and then you will tell us, or tell me to change some of the factors, and then let's see what we'll get. They run very fast. So here is my MATLAB. I don't know if those of you online can see, but it's very perfect, right? So those of us in here, we are having some deficiencies. We can't see everything properly. So I have, to my left, where my current folders are, you see I've got different files. And the files include the compute secrecy features, evaluate CELDA, generate channels, and so on. Now, these are all blocks of algorithms that are intercommunicating. But the screen that shows, which is the secure eigenmode learning and detection algorithm, has got some number of transmitters, number of receivers, number of eavesdrop nodes, the iteration periods, and then power over here. Now, if I run this code here, if I run this right now, within seconds, it brings the output. Let me go back here and that. So this current run, we got 0.97, which is within the threshold we are looking for. Now, we can come back and change the number of antennas to whatever you want and see what result we can get. So maybe somebody can tell us how many antennas, how many transmitters we should change them to. Remember the first one, we got 0.97. So somebody should tell us how many antennas and how many transmitters do you want us to go to? Let's just try. Let's not go very high numbers because we might have to wait for 3 minutes or more. Any suggestion?
60 and 100.
Again?
60 and 100.
Yes, drop 60 and 100. We are going to run it, but the science behind it is the number of transmitters is always almost equal to the number of receivers. But let us try this and see. I have never done it, so let's see what will happen. And the number of eavesdroppers, how many eavesdroppers should we use, sir?
That's it. Okay, someone suggested 10.
Someone suggested 10, so I put 10 in here. I've never done this before, so we'll run once again, and let's see what we will get. When it finishes, it will populate the result, and it is done. Bump, and let's see. We had 0.993, which is a very good result. What I noticed was when the eavesdropper number is greater than the transmitter and the receiver antennas, we get to 1, which we need to find out why. I also noticed another thing in the various simulations, that when the eavesdropper number is very small, sometimes it misses the eavesdropper. Maybe we should try one and see. And let's check this. Good. Also over here, it was able to pick everything. We didn't miss anything. So let us try having same thing, 60, 100, and let's say there's just one eavesdropper attempt. I've changed the 10 to 1. And let's see what will happen. So in this instance, we had 0.999, which is very close to 1. Yeah, and in some of the simulations we've done, when the number becomes very low, sometimes it slips through, the intuition slips through. But when the intuition numbers go high, then the learning becomes a little faster. And so these are solutions we are looking for answers to, and we are still working on. So with this algorithm, we will be able to detect intrusion and eavesdropping in the future full duplex system. We are still working on trying to improve it to make it much better. Others have done some work in the past, but there's been no work that has combined all the variables that we combine. They are mostly either machine learning alone, or either they did energy harvesting, or they did some other, maybe real-time application, or did some other things. But we didn't find any literature that combined all the 5 or so features that we combined. And this is what we've done to be able to identify and detect eavesdropping and intrusion in full duplex MIMO systems. Thank you.
Thank you very much. Please let's give a round of applause. Now, before we take any more questions, I will use this platform to make a special appeal. You see, we have stepped down a visual of at least 1920 by 1080 pixel to a 1024 by 768 pixel because of the projector. That's like 62% downgrade. That's why those of us online on the screens is looking very visible, but those of us in-house, we are struggling. So as graduate students, when you graduate and you step out there, put your heads together and come and donate 100-inch smart TV so that we can phase out this. And then when we have events like this, it will be pleasing to everybody's eye. Whatever we are transmitting, we have a clear visual of it. Why don't you clap hands for that? Right. It's important we acknowledge that. But on that note, we will take some comments, and it will interest you to know that this is our last presentation for today. Yes, so we'll take question from Mr. Azamati. There's a few more hands in-house, and then we'll check online for those who also have questions.
Yeah, thank you for the presentation. Yes, when you started the presentation, you were not able to pinpoint any research paper for which you want to leverage on that to do ABC. But you made us aware you brought the full duplex to enhance communication and reduce the eavesdropping. Now, from research perspective, as far as interference and crosstalks are concerned, researchers develop twisted pair cables to mitigate this. So I wanted to know from you if your research actually seek to address eavesdropping or both interference and eavesdropping. Thank you.
Thank you, sir. So with respect to twisted pair, we are looking at wired network. We, in our research, are looking at wireless communication. And so twisted pair doesn't come in here. Of course, the communication will go through some mediums before it goes through the twisted pair cable. However, during at the point of the wireless part of the communication, that is where we are looking at the self-interference. That is where we are looking at the possible eavesdropping. before the data or the transmission or the signal goes through the twisted pair to the end user's interface. And so we are looking at this medium where we are still in the air interface. And that is the portion we are concentrating our research on.
Yes, but I was saying that we're not able to stand on any paper.
Okay.
Yes.
So some, like I said in the course of my presentation, I had to modify the slides while sitting there because I noticed the time was going and I had to make it a little compact. So I took some part off. So I have some papers I reviewed, and I actually did a summary of the reviewed papers, but I jumped that particular slide. So let me go through a few of them, and then I can tell you what they did. So the first paper looked at towards optimal energy harvesting receiver design in MIMO system. And in this paper, what they did was they harvested the energy, the signals, and look at how they can deal with intrusion in the signal without looking at the eigenvalues of the signal. Now, what they did was they did independent beamforming and eigenmode selection of the intrusion detection and energy harvesting. However, their paper lacked security implication, and that was the part that they did not concentrate on. They did not look at the security rate of the transmitted signal. Also, the second paper I reviewed for this presentation had to do with wireless side loop eavesdropping attack. And this paper also demonstrated that side loop attacks are possible via empirical studies. However, they concentrated on hardware defense only and left the other variables. And we are suggesting that hardware defense alone is not enough. We should look at other scopes apart from hardware defense. Then we also looked at a paper on machine learning for 5G MIMO modulation detection. This paper was looking at just the modulation detection. And in this instance, the paper lacked adaptive and real-world resilience. And so we thought that, okay, let us go beyond what they had researched on. Then we have another paper which is on the development of an adaptive real-time indoor intrusion detection system based on empirical systems of OFDM subcarriers. Now, the researchers looked at real-time intrusion detection via channel state information analysis. What the paper lacked was scalability, and they did not prove how best they can validate their deployment. So, Doc, we looked at some literature, but like I did say earlier on, I jumped them thinking of the time constraint, and I went straight to the presentation, sir.
All right, somebody else also has a question. Go ahead and ask.
All right, thank you very much. So I have two short questions on the algorithm.
Questions, so yes, sir.
Yeah, so first of all, you mentioned that you added Gaussian noise to the formula.
Mm-hmm.
Yes, so I wanted to understand the rationale behind it. Are you using it to simulate the eavesdropping signal, or what really is it doing in the formula?
We did not add Gaussian noise. Gaussian noise is there by itself. So the noise is, for every communication signal, noise is actually part of it. So we didn't have to add the noise to it. It is always there. What we added was the eavesdropping, which is the new component we added. So that is the answer to the first question.
Okay. Right, and then the second one, you made a claim that you used 100 trees for optimal results. I think you mentioned something like that.
Yes.
So I wanted to understand whether that number was taken from literature or it was as a result of some experiments you conducted.
Yeah, so I will demonstrate this to you. So we tried, first of all, using, and I'll show you, I don't know if those of you online can see better, those of us in here. Yeah. This is our algorithm having 50 trees over here, and using the same scenario as we used previously, 8, 8, 4, 1000, and the power being 1. When we run using lesser trees, in this instance, this is what we received, 0.49. Okay. So we notice that when we have less trees in our forest, it doesn't perform that well. When we increase the trees, then it performs well. So it was based on trials, continual trials, and then we arrived at that.
Okay, so if more trees meant better performance, why not 150 or say 200?
It could have been. It could have been. So you are right there. It could have been 150, it could have been 200. But we're also considering computational time. And so that is one thing. For example, the number of iterations, we can change it to 10,000, but it increases the computational time. So it could have been.
Okay.
Yeah.
All right, thank you very much.
You're welcome.
Great. Dr. Clifford, before you come in to, ask your question, there's something that just came up from this question inquiry that was made, and then the submission Mr. Aban just made. Again, Oliver always wants to ask for more. At least from the DCS HCI lab, one of our major constraints, critical constraints, has been computational resources. Now, even just 140 gigabytes of NVIDIA A100 GPU is currently valued at $7,600. That is A1, it's not H100. And these, GPUs are very core and essential, at least to automatic speech recognition models trainings. Yes, Google sponsors have to go and collect the data, but because of our limited resources, you commence one training at this morning, and then you have to wait till evening or sometimes overnight. And so imagine you trying to train a speech model, text to speech, machine translation, then speech to text, and you're like 4 or 5 people. You're handicapped. You wait for one person to, and the sad part of it, you could be training for like 6 hours, and then it will drop because of an error. You have to come in. So everybody remains in queue. These are constraints we find ourselves. So, I don't know. You are out there in Japan. Not too sure if you have resources you can extend to us. I'll put our sponsors on the spot. Definitely will give us a remark as well, because they've taken keen interest, and for the Maiden edition, and they stepping up. You also make a submission on that. Maybe the more support may come, but it's really a challenge and a constraint. So if we get opportunities outside, some of the things some of us are thinking about is, how can I get resources so that my colleagues below here can expand and explore a lot more? See, it becomes so frustrating when I need to train a model or even assess an existing model based on literature, because I could lose a whole day, and yet you have counterparts who need just 5 minutes or 15 minutes to get the same thing done, because the resources are just at their disposal. It can be so frustrating.
36 hours.
Yeah, yes, in his keynote presentation, and of course I'm making a note of that before he asks you his question. He explained the computational resource needed to even train this computer vision thing in his own submission. And it would take time. If we were going to do that for Accra, you would have done this and this before that. Yes, we don't have the resources. If I get your data, I don't have
the computational resources.
The HPC available to us lacks the essential GPU, and that is even being hosted by WAC. Of course, there's CPU, but the GPUs are not there. And we say we want to do world-class research. We are not giving up, but we are using this platform to, present our cases. Once we had a partner, Farmerline, he came on board, he gave us H100, hosted on AWS. And what I spent like 12 hours to do, this thing was done in 15 minutes. I just said, God, this thing cannot continue. Why me? Why am I in this position? Of course, it was just for a short period. We are no longer working with them, but they had it at their disposal. They don't have the expertise, but they also know ready to pay what we need to get things done. So it's a bit dicey. So we really need help to expand on these. Everything has become AI. And all these models they are running on their. This is an Intel PC, and he's training these things. So you have to reduce the figures. Else, computationally intensive. Else we stay here forever. The PC will overheat. You know, these are our realities. But we will not give up. We'll definitely get there. So on this note, we'll give Dr. Clifford the opportunity to ask his question, because he's also been in this domain prior with Prof. Fedi and Dr. Jamal. So, yes, he will make a submission or comment on this. Please go ahead.
Can you hear me, Mark and Fred?
I can hear you. Good.
Yes, we can hear you.
Yes, we can hear you.
Hello?
Yes, we can hear you, Doc.
We can hear you. Go ahead.
Yeah. Mark, I really appreciate it, and I really know computation is an issue back home. And trust me, if you are dealing with image work, it's not even the 3 hours matter that you are talking about. Some work supposed to be run 2 weeks, even using 800 with 40 gig. And that one is when you are using maybe 16 of them, or maybe 8 of them, or 7. So I really know how this computation matter is. And for me, for my side, my institution is research institution. The only way that we can help, or I can have a way to help, that's why I was trying to get a project with the department and my institution. And in that regard, we can buy devices and put it in Ghana, because the project will take place in Ghana. Regarding Gogo, I know Gogo is a business institution, so they will not give you money to buy device and it become the institution owned. They just want to get the data and do product with it. So because I spoke to Jamal about it, so I know that. So let's still work and see that my institution can get something to do with the department, so that as a research institution, definitely we will buy the device and place it in Ghana so far as the research is taking place in Ghana. And after the project, the device become department devices. So that is my take on that. So let's keep on pushing and see if we can still get a project with my research institution and for that to come out. Now, regarding it can be maybe a comment or a question, right? Yeah. Maybe you have run away from me, and I understand why. We talk behind the scene. I know why you ran away from me, but we'll talk about it later. Don't give a comment. I know why. Don't worry. Let me just ask my comment. You see about regarding the graph that you showed about the number of transmitters and receivers. And let me also do let me say that I'm not in networking now, so I may ask the question, maybe stupid question. If it's stupid question, just let me know, because it's long time I've done this networking. Now I'm not in networking, so I may be wrong. But you said that you use 8 transmitters and 8 receivers. But I want to know if this is it the node?
So it's not the physical node. It's the transmitters.
No, I'm not talking about physical node. It's the simulation you did. Okay, yes. Don't go for physical. Don't worry about that. I'm talking about you are using the term transmit. I use 8 transmitters and 8 receivers. Don't forget that initially, you let us know that a node or a device, each device has a transmitter and a receiver. Each device has a transmitter and a receiver. So I just want to be sure that if you say that you are using 8 transmitters, 8 receivers. Does it mean that when it comes to a device, in other words, a node, it means that it's a 4 device and 4 node, because each device will have a transmitter and receiver. Each device has a transmitter and receiver, right? So I just want to know, if you say 8 transmitters, 8 receivers, in that regard, how many nodes are in there?
So, Doc, I'm referring to the number of antennas in each of the devices, the number of antennas. And so you can have a node with 8 antennas in it for transmission and 8 antennas in it for reception. So that is what I was referring to.
Okay, that is clear. So if you say, so in this case, the experiment that you did, that is 8 transmitters, 8 receivers. In that sense, I would say that is 2 devices, is 1 device, right? Because I want to know, it means that it's 1 device.
Yes, Doc.
Can you hear me? The clarity of that. How many devices that experiment? Okay, tell us, how many devices in each of the experiments you did?
So it is 1 device having 8 antennas for transmission and 8 antennas for receiving.
Okay, so in this case, you are not looking at device interference now. For now, it's only a single device that is having self-interference. Is that what you are looking at?
Precisely, sir.
Okay, thank you. Then my last comment, it may be on the latter note regarding your algorithm. If you can show that one, there is something I want to comment. There is an algorithm that you showed on the slide.
Again.
All right, show that algorithm.
Is it this page, sir?
Yeah, this algorithm. Well, just pass it.
This or this?
No, the algorithm. There is algorithm that you should. Yeah, this one.
Yes, sir.
Line 13. You are saying that if a certain condition doesn't meet until the maximum iteration. But if I look at your algorithm, there is no loop. I don't know where the loop and where you are iterating. So I can see that there is something missing. It's not it. So that's why I said this on a latter note. You may have missed it. Because if the algorithm is looping, I have to know on what line that you starting the looping. That when it reach line 13, if you haven't reached the best accuracy you are looking for, and you have not also reached the maximum iteration, you have to loop. So that is on the latter note, so that you check it later on and get the algorithm right. Do you get my point? Because I don't know if I should start looping through line 3, line 4, whatever. I don't know.
I do agree with you. Initially, I was presenting on almost every algorithm. But when I looked at the time, I put this together while sitting here a minute ago. So I've missed a lot of things. Looking through, I can see that there are a lot of things in there. So I really, really appreciate. And I believe next weekend we are going to spend our time together as we always do, sir.
So that's why I said, when you call behind the scene, then you fight behind the scene. All work, I can see that you have improved your work. So well done. Okay, I'm done. Well done, Fred. And I can see you have done an improvement in the work. Thanks to Prof. Jamal. Tell me that I'm waiting for his call.
Yes, sir. And I would have to say that Dr. Clifford and I have spent a lot of time on this work, mostly weekends. We spent 4 or 5 hours. And so I didn't mention his name as one of my supervisors because officially he's not, but then behind the scene, he's made tremendous input as to how far I have come.
And then indeed, you've been hiding from him for a long time. Yes. So Frederick Aban,
Frederick Buafo.
Frederick Buafo wants to ask a question. Frederick, please go ahead and then ask your question.
Thank you, Fred, this presentation. I can see from line 9 that you are injecting an artificial noise. What is the rationale behind that?
So at the end of the decomposition, we would have to restructure the signal back to its supposed original state without the interference. And we would need this artificial noise to help us with the restructuring. And that was why we injected artificial noise. During the decomposition, we were going to affect the original noise. That is why we had to bring in the artificial noise here.
Okay, all right, thank you. Someone initially asked a similar question, but I thought your response was that you are not really injecting any noise. That's how come I'm asking, because I'm seeing that on line 9.
So Fred, the initial question, the way I understood the initial question was from the initial algorithm, which has to do with the desired channel plus the self-interference channel plus an eavesdropping channel plus noise, the Gaussian noise. So I thought he was asking of the initial noise, which is the noise we can do nothing about. That was why I answered in that direction. But if it had to do with the artificial noise, then I guess I addressed it wrongly initially.
Thank you.
You're welcome.
Great. I think he's done the human's job. Let's give him a round of applause. Yes, thank you very much for your presentation. And we wish you all the best as you put on the finishing touches and the fine-tuning stuff. Permanent head damage. There's a reason why we call it permanent head damage. We'll definitely get there. Yes, we'll be fine. Yes. So those who know, they know. Yes, PhD, they call it the permanent head damage. Yes, at this juncture, we will. I know our panelists are putting things together to, determine who is taking home the first prize money, the second, and then the third. But while they do that, I think it will be in order to give recognition once more to our sponsors for this maiden edition of Postgraduate Students Workshop at the Department of Computer Science, University of Ghana. And they are very well represented today. I want them to say something. I didn't want to give them a head start, but I think in my lesson I told them they give them the platform to also make a few remarks. Maybe they could even make some more promises to us and assurances. You may never know. And maybe they have some interest in certain research areas which will drive their businesses in different forms and shape. Well, the platform is open at this juncture. They will introduce themselves. I don't have their phone. Oh, they've stepped out. The two gentlemen who sat over there. Somebody should find them for me. Yes. So whilst we search for them, I think I gave them a head start. They were coming. I didn't even look there again. Yes. We'll take any comments from the panelists for now, whilst we buy ourselves some time for the sponsors to give us a word or two. Oh, yes. One of them is here. Yes. So I was rapping the people about, the support we have received from you. You introduce yourself, please. Come and take the microphone from me. I'll be curious to know how you even heard about this maiden edition. What motivated you? If you have any, remarks, and maybe some research interests you might want to sponsor, some promises, anything. The whole world is listening. Our Zoom audience, our YouTube followers, and those of us in-house. Please introduce yourselves. I've not been this event. I've not heard of you before. Yes.
Good afternoon.
Good afternoon.
Yeah. So my name is Senyo Fiati.
Okay.
And I'm the Chief Operating Officer of Texol Eganow Limited. The name is Eganow. Ega. Then the word now simply means take your financial decisions now. Don't go and discuss your financial problem with your friend, your brother, or anybody. Plan it and have it. So you plan your savings,
You plan your pension. If it is emergency loan, you can easily take it, so that you can have a healthy life. So Ega now is a fintech promoting visibility and accessibility of financial services and products in Ghana and beyond. Basically, that is what we do. We process payment. We are MasterCard and Visa partners throughout the globe. So anytime you want to process payment, we are your partner and will continue to be your partner. Now, we heard about this workshop, and as one of our objectives is also to impact, to support. We are not only in the business of innovation. Innovation here, I would say, non-financial. We can also support a workshop like this financially. Okay. So we look at two things, two problems: non-financial problem and a financial problem. By this program, which we appreciate, which you see the importance for our future computer scientists, there is always the need for us to partner you in order to get the best out of our scientists. Thank you so much.
Wow. We are looking forward to more of this. Yes. We are grateful. We hope that the second edition of this event next year, the money will be more than doubled. And about a decade's time, we'll be appreciating you and remembering you as those who helped us kickstart this kind of event in this department. We have one of the panelists ready to make a few remarks following this event all the way from Wednesday till today, listening in and providing some comments. So the platform is open now to Dr. Selassie Brown of UPSA. Please, kindly go ahead and then give us your remarks.
Thank you very much. I'm so grateful for the opportunity. Mine is going to be a really short one. For the past 3 days, we've been having this workshop, and I must say that this has been a very, very successful workshop. I'm with UPSA. We haven't had one yet, but with the success that I have seen over here, we know who to go to when we want to have ours. I would want to mention that the various presentations were also very insightful, and particularly to say the master's presentations and the papers they presented were very, very, very well articulated when they had opportunity to defend their work. They have actually been able to defend their work very well with a lot of confidence, and I think they really, really deserve a lot of applause as well. The organizers have done an awesome job. I mean, bringing together intellectuals from all over the world, let me put it that way, to have this successful workshop. I'm hoping that in the future, this can actually transform into a conference where a lot of papers may be presented from other universities. We'll also have the opportunity to present some papers during the program. So I'll mention a few names like Professor Ferdinand and Professors Solomon, Professor Edumenu, Mark Mensah, and all the fantastic guys who put this thing together. Where I would just want to say, you have done a yeoman's job, and thanks a lot for coming up with such a workshop. we look forward to the future workshops that you would have. Thank you. And thank you for the opportunity.
Thank you. Yes. We are grateful. If there is any more remarks from any other panelists, that will be gladly welcomed. We are gradually coming to an end. They are computing the figures so that the reward will be mentioned. There were a few posters, but unfortunately they were not in a manner that we can showcase here. But we had one from Benjamin Sylvie Nyame. He was going to talk about graph-based personalized human behavioral modeling. Some of these terms are very mouthful. Sometimes you have to read it 3 times before you actually can decipher what exactly they are trying to do. But to just give us a snippet of what they set out to do as far as the abstract is concerned, let me put that out there. They said they want a human activity recognition using wearable sensors has been dominated by general activity classification rather than personalized patterns. And so while personalized human activity recognition models are effective for user-centric applications, these models are limited by their reliance on extensive labeled data sets. That's quite a very huge argument they have made there, concluding that all these models are effective for user-centric, but they are limited. So I'm assuming all existing models of that nature, they are arguing it out. So it will be interesting to see what they have done. So their study is proposing an unsupervised framework that models individualized behavioral patterns using graph convolution network and then variational autoencoder. They're giving a name to it, an acronym to it. And so by training specialized models for each activity, the framework will capture unique user signatures. They've performed some validations, put out a few F1 scores and AUC scores. And so I think it's not conclusive. So the research is actually advancing scalable unsupervised behavioral profiling, offering practical insights for personalized systems in healthcare and security. It looks quite interesting. They couldn't make it in person to put them out there. Somebody was also going to talk about showcasing research, sharpening skills, a journey to academic excellence. Okay. This is something completely different. I thought it was one. And I think the second poster I have here was exploring the impact of virtual reality on STEM education in Ghana. The quality of the poster was not too good even on the PC to produce here, but I think that the topic speaks volumes. If any of those intended presenters are hearing us, we are grateful for their efforts, and hopefully next time they will actually take the center stage and then make their presentations. Of course, we did have some people who indicated that they were going to present but couldn't make it. Yes, for the first time of everything, it's not easy. We had 2 people bailing out on us today. We have quite a large number of postgraduates now in the department. I'm pretty sure if we put all years together at the master's level, we should have well over 100 master students. And so we have come far, and we'll continue to push this. Do we have any panelists who want to make a submission? Dr. Engineer Seth Alonyo. Yes, we cannot thank you enough for your consistency, but all presentations are over now. We don't know if you have any general submissions you want to make at this point to the entirety of the audience we have in-house, and then those online as well as those following us on YouTube. Dr. Engineer Seth Alonyo, if you have any submissions.
Okay. It's been a wonderful. And, after the coalition, we all get to know who did very well, but generally the performance is encouraging. So I hope that in the near future, they will now improve on what they've done so far and then be able to do an excellent work. Congratulations to all presenters. Thank you very much.
Please, let's give him a round of applause. Now, there is something we've not done in a long while. We have observed some people consistently joining us from Wednesday, yesterday, and today. I don't want you to be a spectator, especially those on Zoom. You know, you have watched us, you have followed us. You know, I've seen some of the faces here. Don't let me call out your names. What has been your observation so far? What do you make of this event? And almost all of them, except from our panelists and the guests, are graduate students. But they've been quiet. They are at the back monitoring. Hey, so this person asks these questions, then I should be careful when I'm on this panel in the future. Hey, look at the way they are criticizing this paper. No, it's all for our well and good. You know, we all receive our fair share of it in this academic discourse. If you have your facts, counter it, educate me, you know, especially when you play into the person's domain. You come and give algorithms and maths here and have proper party here. You enjoy. Yes, any comments from you as well? I can call out quite a number of names, you know. Dennis, you are watching us. I know your name. You are making me call your name. Dennis Boadu is out there. Manuel Ajin, is there any one of you, to make your input? How do you find this? Should we continue this event, progressively, as long as you remain a graduate student, and even for future graduate students? We want to hear from you, and we'll do something nice for our online audience. Those who can turn on their cameras before we leave here, they will turn it all on and we'll take a screenshot. We took a picture the other day, all of us in-house, but they were not part of it. We want you to remain in the history books. But let's take your comment. Dennis, we'll start with you, I guess. And anyone else who wants to speak up, we would love to hear from you. We don't want to just see names, and only panelists talking. Yes, Dennis.
All right. So, Mark, I hope you can hear me. I can. Okay. Thanks so much for the opportunity. I'm some way somehow sad because I was not able to present, but I was able to present, submit a poster in that regard. But I think the next one, I'm surely going to be present. I'm going to participate fully. I must say that this presentation or this conference has been a successful one. I'm highly motivated by some of my colleagues, the works that have been done. In fact, it has been very educative. And I have to give kudos to the department for such an organization. So we are looking forward to seeing more of this in the years to come. Thank you.
Yes, somebody else wants to comment. I heard a feminine voice. We've rarely heard any female voice except from Dr. Engman throughout this whole event. Yeah, and then the lady mathematician, but from our graduate students, where are the females? HOD in his presentation this morning, I was listening as I was coming. He said we have quite a good number of females. I can see some names online. Not too sure if they are graduate. Please don't leave because I'm looking for the females. That's likely to happen. But sadly, it looks like all the ladies have run away. Yes. Yeah, pardon? But we have some females in the house. Oh, yes, Erica Akanko. Can you unmute and give us some remarks? Introduce yourself. I don't know. Anyone knows her? Oh, she did a presentation. Oh, okay. So we had a female presenter. Okay, but what has been your experience so far? I still would want to hear from her, especially now that she's online. Yes, Erica, can you hear us?
Yes, I can. Yes. Good afternoon, everyone. I was fortunate enough to be in person the first day, but today I wasn't able. But I've been following online, and aside my own experience, getting to learn what other people are doing has really been very insightful, and on my part, the ability to put everything together, the confidence to even submit and present was something I had to push myself forward to do. So I'm grateful for that and the entire experience.
A round of applause. Let's give a round of applause. We really appreciate your candid submission. I mean, as you might have realized, a lot of effort have been put in to make this thing happen, especially making this event hybrid, such that those outside can make their presentation, speak to us in-house. I can assure you everything we have used here is borrowed, except from this projector. I won't shy from saying that every single item, aside from this projector, is a borrowed gadget. And so from individuals in the department, graduate students, etc. Yes, I mean, for example, the speaker that has enabled us here, everybody, is being extended to us by Mr. Soli. Just to begin with, this camera is from Professor Yafe, so it's all been borrowed. But we would want to, in the future, have permanent setup. For this is our best meeting space as far as the department is concerned, if you are listening to us for the first time, especially those outside. So for those of us who also step out there, let's look back. We can get these equipment permanently fixed in here. Now we are covering our faces again, just as we did a few years ago. If everything turns out virtual, this is the way we can have people in person and hybrid and deliver meaningfully, and everybody can be engaging, in a nice fashion, irrespective of time. So we are hoping that by the next event, the sponsorships will not just go into other things, but to be extended to instances where we have permanent setups across our small rooms, so that it could be a very nice and engaging event. So yeah, that is just my submission on that bit. So at this point, you give us a small interlude on the background whilst we take the final results, and then we wrap things up, the purpose for which we are here. Please, those online, don't leave just yet. I mean, you also deserve a round of applause. So I want all of you to give yourself a virtual clap. Those of you online, we are watching you, a virtual clap, so that we know you are there. We really, really, really appreciate your time. I'm pretty sure it is almost late midnight in Japan right now. And Dr. Clifford has stayed through from Wednesday to date, from first presentation to the last presentation. I mean, his commitment is unwavering, and we are really, really grateful. Our counterpart from Utah is very early in the morning. I'm pretty sure somewhere within 9-10 a.m. and he still managed to add us to his schedule. We are really, really grateful taking time out of his schedule. Dr. Engineer Seth Alonyo. I'm wondering whether nothing is happening on his campus. The way he's dedicated his time every one of these days to stay through. You check online and he's still there. He's giving feedback consistently. It's amazing. This shows the dedication of these personnel. As for YouTube, I'm not checking right now, but if you are following us there too, you can give us some recommendations. Even the channel we have broadcast the production is borrowed. Hopefully we'll have our permanent channel in the future. Let me put that across. It doesn't mean you should not subscribe. If you do, we will love it. Yeah, but it's all well and good. So I'll chase after the figures at this point. Kindly give us a few interludes. Please stick and stay. Don't leave yet. Let's see who is taking home the reward, and then we'll take a few remarks from the committee chairperson and the HOD, and then we'll wrap it up. Did you mistakenly call me? Hello. Yes. He has cut the sound completely. Keep it on the low. Yes. The moment we have been waiting for is already here with us. Yes. Yeah, I'm sure you can hear me. We have our 3 top presenters for this maiden edition of Computer Science University of Ghana Postgraduate Student Workshop. Yes, and to make the presentations, we will invite our Chief Executive with the sponsors to join us, Chief Executive Officer. Please join us on stage. You make the presentations to our winners for us. Please, let's give a round of applause. Oh, I'm waiting for my virtual applause. You are so important to me. Please bring them up. Yes, thank you, Dr. Jan. Thank you, Isaac. Thank you, Michael Aban. Awesome. Right. Do you want to know do you have our awardees here? If the awardee is not here, because they don't know themselves, I'll possess their prize. Right. So the time we have been waiting for is right here with us. We've received a lot of presentations since Wednesday till today. Very, very insightful. These have been, reactions we have received from both those of us in-house and then those who have joined us virtually on Zoom. Our sponsors have already made a few remarks and we are grateful continuously. We will not take that for granted. Third, on the presentation. A minute. You have no minute is too much. Yes. I can give you a clue, of what these presenters worked on. So, one of them made a presentation on. Okay. You have the packages here. Okay. Yes. So somebody made a presentation regarding missing data input techniques. challenges, innovations, and applications. Conducted a review on that. Okay, for all visitors. Yes. So this was one of the, awardees' presentation, and this is no other person but Mr. Prince Samuel Chematin. Please, a round of applause for him. Mr. Chematin came third in the presentations. Please give him a round of applause. He deserves it, please. And the paparazzi is in the house. Make sure this goes into. Please, we are taking the virtual claps. Oh, awesome, awesome, awesome. Clap your hands for them. We are grateful. Yes, 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 yes. Awesome, awesome. You can keep my sound a bit under the picture, the sound, so that the place is still colorful. Yes. Awesome. When you are done, let us know. Yes. He's taking his own prize money. Amazing, 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 amazing. Yes, 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 yes. Awesome. Please don't sit yet. All our ideas are coming to you. Then, the first runner-up for this event, he made a presentation to us. I believe he did his yesterday, if I remember correctly. Early detection of geriatric depression. You know, that interesting presentation I've made mention of. It's mouthful for me, forgive me. Using AI and predictive analytics. He also conducted a systematic review on this. Ladies and gentlemen, this is no other person than Mr. Prince Ofori. Please don't forget when you're going to buy the gobe. Yes, it's one of the staple meals for the graduate students. Oh, I've given somebody this award to somebody else. Yes, it's a maiden edition. We are bound to make mistakes. Prince, you did well. You will get a certificate. Bear with me. Yes, you can smile if you are online, but these are some of the things that happen. I won't even keep quiet at all. Because they all use the surname Ofori. Ladies and gentlemen, please, first runner-up is Eric Ofori. Eric Ofori. Eric Ofori. Yes, Eric Ofori. He's not here. Is he here? He's not here. He's in Australia. Eric, are you online? He's not online. You see, I said those who would not be here, their reward is what? He's under your supervision. Oh, okay. Okay. Right. Well, he has won it. We have kept it here. You will get it later. Don't go and post on LinkedIn. It's not your reward. Yes. So they will arrange and get it to him. Eric Ofori has won the prize money. However, every presenter is taking home a certificate. That is guaranteed. So nobody's leaving here without anything, especially those of us who presented. So the best presenter on this maiden edition of postgraduate student workshop at the University of Ghana Department of Computer Science, the award goes to Albert Ankuma Dodu. Please give it up for him. Oh, give it up for him. Virtual claps. I'm taking my virtual claps. Virtual claps. Please give it up for him. Give it up for him. Please. Come and take your reward. Yes, 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 yes. Yes. Please make sure this is on LinkedIn and all the posts. Oh, I trust him. It will go on LinkedIn. Yes. Yes. Yes, he worked on the malware detection. I think you presented on the first day. Yeah, I listened to him online. Yeah. Great. We'll do that. Yes. Now, like I said, we have certificates for all presenters. And because some are virtual, some are not here, etc., we'll have them ready. You see the postgraduate coordinator. I think he will work with the administration. You come and pick it up. Please, let's give him a round of applause for all our presenters. Now, this event wouldn't have been possible without our sponsors. These awards we are giving out is all by their efforts. And so, by way of appreciation, we also have a special presentation to make to them. And I mean, for that to be done, we have our coordinator, postgraduate coordinator, chairperson, Professor Ferdinand Katriku, to do that for us.
So yes, so this goes to the Chief Executive of Egano. Thank you so much for your support. We look forward to working with you in the future. We really, really appreciate your help with this very lady. We called on him at very short notice, and he was out there willing to support us. So we thank you so much. This is something so much.
Awesome. Yes. Yes, thank you so much. Thank you so much. I don't know if you want to make a statement.
Well, I mean, it's great. It's always great to support such an initiative.
Okay.
We are always available as a fintech, as a company, to contribute our little support towards the building of our future scientists. Thank you all.
Thank you. Right, so the moment we've been waiting for has finally come. The takeaways is all in the hands, and the closing remarks are all in the hands of our postgraduate committee, the chairperson and his able assistant, Professor Ferdinand Katriku, and then Professor Solomon. And once they are done with that, we will take a closing prayer from an MSc student, and we'll take pictures, and that ends it. Please, my virtual team, please, if you are not wearing a shirt, put it on. Like I said, we'll take the pictures with you. We'll take a full screenshot. You were part of it. If you were not there, it would not have been successful. I think on average, since we started, we've had on average about 50 participants, 50 to 40. We've risen all the way to about 80 to 90. And it's been really good for a maiden edition. So please, we'll take your closing remarks and then we'll get a prayer.
This event. Thank you.
Cool. Thank you so much, my chairman. I don't even know how I can say it, but let me give it a try.
Yes.
It hasn't been easy. It hasn't been easy, and I'm so much happy. At the end, we have come to a successful end. The main thing was that it started like a joke, but as my HOD already mentioned, but we have been able to put it together, and we thank Almighty God for the support, the strength, the ability to be able to put this together for our postgraduate team. And I'm hoping that it will not only end here, other departments, other universities will also try to do this to encourage postgraduate students to be able to not to give up, but to always try to get it done. So first and foremost, I think I will have to say a very big thank you to the Almighty God. On behalf of the postgraduate committee, we are much grateful to the Almighty God for giving us a conducive weather. In fact, this morning when I woke up, I realized that there were some little showers. And I said, hey, God, you have been able to do this first day, second day, the last day. And then we showered a prayer. My lab, I really have to say a very kudos to all my lab members. You've really been very good. My chairman has nurtured me a lot. I've learned a lot working with him. I will never forget the day I was trying to... Chairman, I can go ahead and say it, right? Today I will say this. In fact, when I was doing my MN computer engineering, it was a time I wanted to publish a paper. And I sent it to him. I will not mention the title of the paper. He took his time, went through it. He gave me comments. I worked on it. I sent it back. He did it again. I went on it. So when I was doing my PhD 2015, 2018, and I realized that I had a reflection of the paper. And I realized that no, this paper shouldn't have even been taking time to actually get comments. You should have just said, Solomon, no, put it down. But he encouraged me. In fact, he made me not to give up. So sometimes if you see me and you talk to me, you realize that I always try to encourage you. The source is for my chairman. Because later I realized that he would have been someone who would have said, no, Solomon, this paper is no good. Do it in a different way. But he still was trying to bring out something best in me. Until later I realized that no, this paper is not a go area. So I have to change it. And I'm really, really much happy. I've learned a lot from him. And not only him, from also my my other postgraduate committee member, Prof. Winfred Yakuma. They have really, really been a good support to me. Sometimes the going gets tough and I get stressed a little, and they encourage me not to give up. And it's not easy, but I'm really, really much happy. So on behalf of the postgraduate committee, we want to thank Almighty God. We also want to thank our HOD for making it a success. It wasn't easy. We want to thank all the people we invited to the program, right? We will kickstart by, in fact, thanking EGA now, right? Without you, this 3-day workshop wouldn't have been a success. We are much grateful. In fact, one of the secrets I have to pour out here is that we were able to get in touch with EGA now through one of our MSc students. In fact, I'll mention his name, Isaac Forsen. And I really want to say that he has really done well. Without him, I don't think this has also been a success. So kudos to him. In fact, there are other people I'm supposed to mention names, but they have actually told me I shouldn't do that, so I'll not do that. But we need to first and foremost also thank our provost, the provost of College of Basic and Applied Sciences, Professor Mark Shadow Idana, for making it a time during the first day to come in here. The Dean of School of Physical and Mathematical Science, Professor Kwabena Dokuan Ponsa. We are much grateful for also coming in here. We can't forget the Dean of School of Graduate Studies, Professor Robert Osedakun, together with her Vice Dean coming in here on the second day to be able to help us have a very good interaction. Those of you who were here yesterday, you saw that there was a nice interaction happening, right? So we are much grateful, Professor Osedakwe and Professor Irene Crunchy, both the Dean and Vice Dean respectively. We are also much grateful to our the Editor-in-Chief of Sibas Journal, Professor Elvis Tiburu, for making it time to be here on the first day. In fact, we cannot forget all the heads of departments. The day 3 was actually for heads of department. So we had a head of department coming across board from everywhere, right? And we are so much happy to the head of department of Lancaster University, the Department of Computer Science. We are also much happy to, that is Dr. Pius Kaukadese. We are also happy for the head of department, Department of Computer Science, KTU, Federal Technical University, Dr. Seth Alano. We have been so much grateful because day 1, day 2, day 3, you were online with us. We are so much happy. In fact, we can also not forget about Professor Frimpong Chum from KNUST. You've also been great support. I can also forget, in fact, Selassie Brown, who has also been online from day 1. We are much grateful. Dr. Felicia Engman from Gempa, we are also much grateful for being here. Dr. Patrick Kujo, I cannot forget you, my brother. You have also been so much supportive in what we have been doing here. In fact, all that we can say is we are much grateful. In fact, I cannot forget my MCs. Oh, my goodness. My goodness. My goodness. The 2 MCs made the program to a different level. They catapulted it to a different level. And I'm much, much happy to Makata Mensa, my colleague, my friend, and also Michael Soli, my colleague, my friend. You guys have done so well. I think we should clap for them. In fact, we cannot forget the technical team members and also the students who dedicated themselves to help in the catering and preparation, right? If I have to mention all the names, I would give it a try. Endurance, Sandra, you've done well. Kingsley, Kelvin, and then Lizzie. Hey, I can't forget you.
He's Elikem.
Elikem, you've done so well, right? In fact, all the people that supported for this thing to be a success, we are much grateful. And there's one person I cannot forget. My brother. I know you are online. Professor Kofi Edumenu. In fact, he's not even in the country. This morning we had a long call. In fact, some of the things we actually put together, he brings on the table, says, Solomon, let's talk. Before we hit the committee table, Kofi and I, we have a lot of stuff together we do. And I'm really, really much happy and grateful for what you have done, his support. The postgraduate committee, we are really happy for that. In fact, all the presented, on behalf of my postgraduate committee chairman and the entire postgraduate committee, we are really, really much happy for dedicating time to put all your papers together and coming to present. Stand here to present is not easy. Getting you guys here to come is not easy. I will not forget George. You've done your best. I'm really happy. I will also not forget everyone. George did so well. One of your support you've done, I'm not going to mention name, but you've done well. And I know God will bless you for that, right? So some of the things we have seen here is all about the students coming together in partnership with the sponsor to be able to help us grace this occasion. And we are really, really, really much happy. All that we can say as a postgraduate committee is that God bless you. And then we are hoping that in the next event, we are going to be able to do another thing else, and we need all your support. Those online, you can say kudos. You have done so well, right? I can see Dennis. I can see everyone. Charles, I can see you.
Yes, Samuel Mensah, I recognize you.
Yeah, I can see everyone. Frederick Wafo, I can see all of you. We are really, really much happy. And all we can say is thank you on behalf of the postgraduate committee and the head of the Department of Computer Science and all my faculty members. We are much happy. All faculty members that came in, Prof. Yafe, Dr. Matoda Wilson, Dr. Anson, PBS, I saw you join online, and everyone, those have forgotten names, please, we are much happy. Thank you, and all of you, God bless you. God bless you. God bless you. Thank you.
So we would need, this point, I'll call a volunteer from the postgraduate class to come and give us the closing prayer. Yes. I don't have much to say after all of that, so that we don't say anything. Who will volunteer to say the prayer for us? Oh, yeah, I should put it around his neck. Yes, yes.
Kindly let us pray. Father, we thank you this afternoon for such a day like this. We are so much grateful for starting with us and bringing us to a perfect end. We pray for your goodness as we travel to our various destinations, that you will send us and bring us again at appointed time. We want to thank the coordinators and also the leaders of this great vision. We pray for mercy for them. We pray for goodness, and we pray that you will bless them bountifully on what they have done. Once again, it's a good seed that have been sowed. We pray that you shower your blessing on it. Next year by this time, it will be bigger, it will be greater, and it will be nicer than this. These are many things we ask through your Son, Jesus Christ. Amen.
Amen. So this is where my online team, please turn on your cameras. We want to take a screenshot. Those of us in-house, I think there's a photography. We all gather here on the backdrop, and then we'll take a picture. Thank you very much, and see you in the next event.
All right, so this is the last thing. It escaped me, but I have to say it. In fact, our keynote speakers, we are much grateful, right? Samuel Bedu, in fact, Dr. Bright Ajiman, and our one and only Dr. Clifford. It escaped me, please pardon me, right?
Sure, he's going to sleep.
All right, so thank you so much. All the keynote speakers that made it a point to be here, we are much grateful. Thanks so much. God bless you all.
All right, Ellie, can please take a picture of those on Zoom. Their cameras are on. Take a full screenshot for us. And the rest of us in-house, please, can we move upstage and take a picture? Some people are still, cameras are not on for some people. Some cameras are still not on. We will share it with you so that you can make your posts. Some cameras are still not on. They are turning on their cameras. Yes. Keep turning them on. We are taking a picture with you. The paparazzis, the iPhone people, please. You as the honest. No, don't use Dr. Prof. Solomon's phone. I don't picture for us. Come and take the picture for us. Oh, make sure you are getting everybody. Come and stand in the middle. You come and stand this way. Find another phone and then pick for us and take a picture. Yes. Make sure we are all, and let them keep taking the online. You want to be part, eh? Hey, some people, please let's give them the chance. Eh? Yes, one more. Welcome. Hurry up. Last one. Last one. Oh, come and pick it. Thank you. Oh, we even borrowed the sound we are using so that YouTube will not block our audio. So it's also open. Yes. Thank you online. See you next